So thanks for joining us for the Dapper workshop during the Azure Community Conference. For us, it is 6:30 in the morning, so it's a little bit of a weird timestamp to be up. Not for me. I'm pretty much an early bird, so I really like this time of day. But maybe people joining from different time zones. Welcome everyone.
Love to welcome everyone to this day of Azure Conference. This year, Azure Community Conference.
We have some, maybe people, yeah, I think it's muted now. Yeah, thanks for that.
Yeah, it's fixed. Yeah.
Okay, so people will be coming into the session, but that's fine. We'll just carry on. So let's go into the day. It's going to be quite a long workshop. First of all, let us introduce ourselves. My name is Edwin van Wijk. I work as a principal solution architect for InfoSupport. It's a company in the Netherlands. I'm also a Microsoft MVP in the developer technologies category. And I have a lot of experience with cloud native distributed applications, microservices, and we got interested in Dapper and wanted to be experts on that topic. So we started working with Dapper, and this is one of the results of that. And today I'm joined by Sander. Maybe you can introduce yourself, Sander.
Yeah, good morning, everyone. My name is Sander Molenkamp. I also work for InfoSupport in the Netherlands. I'm a principal cloud architect, and I'm a Microsoft Azure MVP.
Yeah, so and today we're going to tell you all about Dapper. If you, after the session, want to learn more about Dapper or want to have some more inside information, you can also pick up our book. And with pick up, I mean virtually, because it's an online book. You can download it as a PDF or read it online. And that's Dapper for .NET developers. And the link is up here. I will share the link again at the end of the session. And in this book, we describe Dapper and how you can use it. And the application that we're going to look at today during the workshop is also the application that was the sample application that we use in the book. So if you have followed this session, you will recognize a lot of stuff. But maybe you can go back to the book later on to get some more information. If you want to see more of us talking to all kinds of cool guests that we have in our YouTube channel, it's called .Netflix. We have a lot of topics, mostly around Microsoft technology. If you like that, then go to our channel, youtube.com/.netflix, and please subscribe. And with that, let's go into today. And what I would really like to know is how many experience with Dapper we have in the room. So if you would be so kind, if you want to share in the chat in Teams what your experience level with Dapper is. And then we have 1 through 5. With 1 being, well, Dapper's completely new to me. I've heard the term, but that's it. All the way up until, I use Dapper in production workloads today. So I'm really curious. So if you could share this in the chat, that would be great.
Okay, so I don't know if you can see Edwin because you are also sharing your screen, but we are getting 11211.
Yeah.
2. Oh, a 4.
4. Okay. Hope we can learn you something new today. Yeah, so please keep them coming in. So that would be awesome. And maybe we will, when new people come into the channel, maybe Sander, you can post this question also, that people see that in the chat, so they can share that information. So thanks for that. So this is what the session is going to be looking like. We start with an introduction. Well, basically, we're busy with that now, obviously. Then we're going to do a Dapper 101. And this Dapper 101 is actually for people that don't have any experience with Dapper. And I saw some people with a score of 1 and 2 coming in. So that's awesome. Maybe people that have seen some Dapper before, this will be really basic stuff for you. But please bear with us. And then after that, we will dive into the workshop case that we're going to be working with today and the sample application that comes with that, and share you the details of the workshop and the rest of the day. And then basically, let's already introduce you, then have a choice to make. You could either stay in the Teams channel and watch us do all these sessions live. So we will just do this, the assignments that are part of the workshop. We will do them live for you. Or you can either go and use the Dapper workshop instructions that we will share later on to do it yourself. So you can also start coding hands-on today if you want. But more information on that later. And then we will go into several sessions that we will introduce all the Dapper building blocks. At around 12:30, Indian time, we will have a lunch break of around 30 minutes. And then we will go on. And then at the end of the session, we will have 2 modules, so to speak, or 2 topics that are basically extra when it comes to the workshop. So those are not in the hands-on instructions. And that's about actors and observability. And then we want to have some time at the end to do a Q&A. So you can ask questions in between. So if you have any questions, please post them in the chat and we will try to answer them as quickly as possible. But there is also some time at the end. So if you have a question that goes a little bit outside of what we're talking about right now, please wait until the end and then we will have the opportunity to answer those questions.
Yeah, just to elaborate on that a bit, maybe Edwin Edwin and I will both be doing the live coding, and
Yeah.
of course only one of us is live coding at a time, otherwise it would be chaos. So the other one can monitor the chat.
Yes.
However, we are both pretty busy with that. So if you choose to do the hands-on exercises yourself and you get completely stuck, also post in the chat, but we can only help with the more general questions, right? So if there's something on your machine that's not working correctly, like Docker or stuff like that, we'll probably won't have the time to completely help you with that.
Exactly.
However, we've run this workshop now a couple of times, and what we usually see is that if all the prerequisites are running correctly on your machine, then almost everybody makes it through the hands-on exercises without any problems. So you should be good to go.
Yes. Okay. Well, thanks for stating that, Sam. Yes, and like I said, if there are some questions, we will look at the chat as closely as possible in between the sessions. So yeah. So with that, let's dive in. What is Dapr? Well, Dapr stands for Distributed Application Runtime, and yeah, that's exactly what it is. It is a runtime and a set of tools and building blocks for building distributed applications or microservices applications, as they're often called. It is cross-platform, so it runs everywhere basically, and yeah, you can run it basically everywhere. You can run it on your machine, in the cloud, basically wherever you can run it. If you want to have more information on Dapr, there is a website from which you can get all kinds of information about the community, the product itself, all the repositories, and that's dapr.io. So go there if you are starting your Dapr journey, so to speak. What I think is really important to stress here is that Dapr initiated at Microsoft, but it is an open source product, and it's completely supported by a large community of contributors and maintainers. Some from Microsoft, but also some from other companies and also people that are freelancing and stuff like that. So it's a really vibrant community nowadays. And Dapr can really help you to focus on building business software, adding value for your customer without having to focus on these cross-cutting concerns that we almost always see when you start building microservices or distributed applications. So a lot of cloud native applications, they need pub/sub messaging, or they want to have a way of calling other services within the application. They want to do some state management. They want to handle secrets. A lot of those cross-cutting concerns often take up a lot of your time because you have to build some abstraction for it because you don't want to be tied to a certain implementation. And that's basically all time that you need that you don't can spend on adding business value. So that is what Dapr can help you with. It will take care of these cross-cutting concerns. So how does Dapr do that? Well, Dapr is basically a collection of building blocks, and these building blocks offer several capabilities. And you see them here, and I will go over them quickly. But during this session, obviously, each of these building blocks will have their own, well, chapter, so to speak, and we will dive into them in great detail. So the first one is service invocation. And as the word implies, it is for invoking other services within your distributed application. And that includes, for instance, naming and localization. So where or location of the service, where is it and how can I call it? You don't need to know where it is anymore. Dapr will take care of that. And that's what service invocation is. Then we have state management. With state management, we can store state, which is basically not an ORM, right? So it's not an abstraction of an entire database, but you can share key value pairs. So it's a little bit simpler, and it's for conversational state or stuff that you need to store, like for instance in a shopping basket or whatever. So that's state management. Publish and subscribe. We all know the pub/sub, the publish subscribe pattern. Well, this building block will offer capabilities for doing that. So it will abstract some message broker that you will use for sending and subscribing to messages. And that's what the pub/sub building block will offer you. Then there are resource bindings and triggers. And these are ways of integrating with systems without needing to know how they work. And that's a little bit of an abstract description, but for instance, if you want to send an email through SendGrid, for instance, then you don't need to learn the API for SendGrid anymore. You can just use the Dapper of the Dapper building block, the resource binding for SendGrid. Or if you want to receive events from EventGrid from Azure, for instance, you don't need to know how that works. You can just use the trigger or the input binding, as we call them, from Dapper. So that's really cool. Then there's the actors building block. So Dapper offers a virtual actor model. Sander will talk about that at the end, one of the session at the end. And that's the actor model. That's a programming paradigm that's a little bit different than the traditional way of building services. It's a really cool way of solving certain problems. And like I said, Sander will dive into that later on. Then there's observability, which is, in my opinion, one of the most important aspects of distributed application programming. You need to have observability into what is going on within your application, especially when things go wrong. You want to be able to know where it is, where is the problem, and maybe even have dashboards and alerting and stuff like that. So really important. We'll also look into that later on. Then there's secrets management. You often in your application, you have some sensitive information like, passwords, API keys, subscription keys, and stuff like that. And you don't want to push them to GitHub, so to speak. You don't want to beat them. You don't want it to be out in public. So that is where you can use key management or secret management systems like Azure Key Vault or HashiCorp Vault, or maybe even Kubernetes secrets, for instance. And the Dapper secrets management building block will help you with abstracting that. And then it says extensible because it is open source and there's a vibrant community. So we think that in the future, several building blocks will be added so you can even have more capabilities to build distributed applications. So this is in short the collection of building blocks that we're going to be talking about today. And why is Dapper a little bit different than other, well, basically abstraction frameworks that you see out there in the industry? Well, Dapper has a standardized HTTP or gRPC API that it offers to your application for using these capabilities. So you don't need to know any specifics around the abstracted systems or the abstracted components. You just call the HTTP or the gRPC API. And that means that from basically every programming language, every platform, you can use Dapper. Of course, it is possible to just use the HTTP or gRPC API directly, but also sometimes you want a more convenient way of integrating with Dapper, and therefore there are a lot of SDKs out there already for .NET, for Java, for Python, for lots of different, also a PHP one is there. So there are also SDKs that make it even easier for you as a developer to use Dapper through these SDKs. And then finally, Dapper can be integrated with lots of different environments. So obviously with ASP.NET Core, you can run it in .NET, but also there's integration with Azure Functions, Azure Logic Apps, API management, Spring Boot. So you see that there are a lot of places where you can use Dapper, and this will grow significantly in the future, is our opinion. So this is how Dapper offers the capabilities to you. So how does that work at runtime? So if we look at how Dapper is deployed, it uses a sidecar pattern, and the sidecar pattern is really important to grasp and to understand how this works, because it's this is mostly where people go wrong when they start working with Dapper and they have something that doesn't work. You really have to think about, okay, how does this work? My application is running, and in this case, I'm looking at application code on the left, which is basically your application, your service, your microservice, and then this is running just as a process on a machine. It could be your local machine, it could be some server. And then when you introduce Dapper to it, it will add an additional process which runs alongside your application code, which is the Dapper sidecar. And then over local network, your application code will communicate with the Dapper sidecar and call into the APIs that I've just showed you. So this is one way of doing that. And this is, like I said, really important to grasp because, yeah, you're basically calling your own Dapper sidecar to do all kinds of things, like sending a message, calling a binding, whatever. Well, this way of hosting your application with Dapper is called self-hosted, but there's also another way of running it, and this is actually the preferred way when you look at production workloads, and that is running it in Kubernetes. And this conceptually is exactly the same. So again, you see here your application code, but now it is deployed as a container within a Kubernetes pod. And the pod is basically the smallest unit of deployment and versioning within Kubernetes. So your application runs in the pod. And then when you add Dapper to that application, the Dapper sidecar will automatically be injected, and there's a second container running inside the pod. And then your application code over the local network, because they run in the same pod, they can reach each other, and then your application code can reach the sidecar container. So, like I said, this is really important, and we're going to look at that a little bit more later on. So let's look at an example, and then Sander, I will give it over to you to introduce this this example.
Yeah, thank you, Edwin. Let me switch to my other to PowerPoint where we left off. Yeah, so let's make this a bit more concrete. So let's say we are running a Dapper application in Kubernetes. So that would give us a single Kubernetes pod with two containers, your application container and the Dapper sidecar. Now, as Edwin just explained, we use that sidecar pattern, which really allows us to use all kinds of different platforms and languages. So this application code could be Python, C#, Rust, I don't know what language you created yourself, anything, as long as it can send HTTP or gRPC requests to that sidecar. Now, let's say I want my application to be able to store some state, to persist something. Now with Dapper, that is really easy. I only need to make a call to the Dapper State Management API on that sidecar. And then Dapper will use a configured state store component to actually store that data. So let's say that in this example, I've configured Dapper to store the state in a Redis cache. Now, if I change my mind later on, or maybe I'm going to a different environment, I'm moving from my development machine to a test environment or to a production environment, I can change that state store really simple by just modifying that configuration. So for example, instead of Redis, I can change the state store to, let's say, Cosmos DB. And it's important to note again that I don't need to modify any code for that. It's completely transparent for my application code. It's all being done through configuration. So let's expand this example a little bit further and assume there's this second service, creatively called service B, which is also running in Kubernetes. Now, if I want to call this second service, I don't call it directly. I use my local sidecar. So in this case, I'm using the service invocation API of Dapper. And then my local sidecar will communicate with the remote sidecar, and that remote sidecar will finally invoke the actual service. So there are definitely some benefits of doing it this way, but we'll look deeper into service invocation, what those benefits are a little bit later in the session. First, I want to show you some actual code. All this code will be done in C#, but basically everything Edwin and I will show you will be C#. The workshop exercises also contain instructions for Java or Python. So if you prefer those languages, you can choose to use those languages as well. So let me switch to a different machine. So this is my development machine, which is Mac, by the way. So I'm on a Mac, Edwin is on Windows. Dapper has cross-platform support. It can run in many different environments. So you can also run from Linux. And I've got Docker for Desktop running here. And I've also installed Dapper on this machine. Now, when you install Dapper for the first time, you start by installing the Dapper CLI. And you get this Dapper executable. So if I run this, maybe make this a little bit bigger. You can first off see some cool ASCII art and then all kinds of Dapper commands that you can execute from this CLI. So once you've done that, once you've installed that CLI, you can set up your Dapper environment by running this init command. So you can run Dapper init. And that command will install the Dapper runtime binaries and a couple of container images on your local machine. And there are two variations of it. You can use -k to install Dapper into a Kubernetes cluster. If I run it without -k, it will install Dapper in that self-hosted mode Edwin talked about, which is great for local development. So that's what I've done here. And again, in self-hosted mode, there's no container orchestrator. The microservices and Dapper Sidecar just run in their separate processes on my local machine. Now, the one thing I have to be careful about is that because everything is just running as local processes, I need to really carefully choose all the ports, because a lot of Dapper sidecars will be running on my local machine. They all need a unique port number, so there aren't any conflicts there. Anyway, I've already executed Dapper init, so it's installed on my machine, and I can prove that by running Dapper -- version. This shows me the installed version number of the CLI, which is 1.4, and the installed version of the runtime, which is the very latest officially released version, which is 1.4.3. If you are still running on 1.4, I advise you to upgrade to 1.4.3 because there are some hot fixes in there. Now, as I said, Dapper init also installs some container images, so we can do a Docker PS to show what exactly is installed. And we can see 3 containers. So there's, first of all, there's a Dapper placement container, which is the middle one here. So that is required when you use the Dapper actors building block. So that Dapper placement service is responsible for basically distributing all the actors across all the instances of your, or all the nodes of your solution. And then we've got 2 open source projects going on here. We've got Redis, which is the default backing store for both the pub sub and for state management. And then Zipkin is used for distributed tracing, and Edwin will show you how to use that later on. So Edwin is already answering a question in the chat about, so when you run Dapper -- version and you don't see any runtime version yet, that means probably that you still need to run the Dapper init command, or you try to run it and it failed because maybe Docker is not running yet, or something like that. All right, so I do have the binaries installed. So let's see what exactly is installed. And if you run Dapper init, then on a Mac, the default installation directory is my user folder and then .dapper. On Windows, it's your user profile folder, and then there's a .dapper folder inside of that. So let's open this up in Visual Studio Code. And we can see a couple of things here. We see a bin folder, which contains the runtime binaries. We've got a components folder, and we've got this config file. So let's look at this config file first. So this is a default Dapper config file. And each application that uses Dapper can use such a configuration file to specify settings for things like tracing and metrics. So for example, here you can see that tracing is enabled because we've got a sampling rate of 1. And we want to push those traces to Zipkin, and Zipkin is listening at this local address. So this is that container that is running. You can do a lot more here. You can add middleware components to inject functionality when you call other services. It's also used to configure some security settings. Yeah, all kinds of general configuration for your application. Now, this will look a little bit familiar if you're used to Kubernetes with the metadata and the spec. That's because this is in the form of a Kubernetes custom resource definition. In self-hosted mode, like I'm running now, this is just a file on disk, as you see here. But if you're running in Kubernetes, then you need to apply this configuration to the cluster, just like you need to do with any other Kubernetes manifest file. Okay, so let's move over to this components folder here. This contains 2 component configuration files. So one is for the pub/sub state management block, and one is for the state store. So these are just default configurations so that you have something to get going just straight out of the box. So let's first look at this pub/sub one. Now, first off, you need to name your component so we can refer to it from our application. And then the other really important thing is you need to specify what type of component this is. So this is pub/sub.redis, which means this is a pub/sub component which uses Redis as the underlying message broker. And the first part here is equal to this name, but that's purely coincidental. I think it's a little bit confusing that they've chosen it this way, because I could also call this foo and it will still work. But by naming it pub/sub, it kind of implies that there's a relationship between these values, but there isn't. You can name it anything you want. So then you have in this spec section, you have a bunch of metadata, which will differ, of course, depending on the type of component that you're configuring. So in this case, we need to configure how to connect to Redis because we use Redis, and we need to know where Redis is hosted. So we need the host address, and we also need the password, which is this really strong, secure password by default. All right, so let's switch to the other component, to the state store. Now this configuration is really similar. So in this case, the name is state store. The type is now state.redis, which means it's a state store component with Redis as the underlying infrastructure. We also have slightly different metadata because this component also uses Redis. We, of course, again see the Redis host and the Redis password. But now we can also specify for a state store if we want this state store to be the one that stores the actor state as well. And again, I'll be diving deep into actors at the end of the session, so we'll revisit this. Now, if you don't specify a custom directory when you start your application with Dapper, then the runtime will simply use this default components folder. So it will by default load these two components for you. And let's see this in action. So there's a question in the chat, where are all these files? Did you make them? Do they come with Dapper? So these all come with Dapper once you run that Dapper init command. All right, so let's write something ourselves now. So I'm going to create a really simple banking application, which will just allow us to check our balance, add some money, withdraw some money. Really simple, but it shows off the power of Dapper and how quickly you can create something that actually stores state without you having to write a lot of code for it. So this is going to be, oh, I can't type. This is going to be a ASP.NET application. It's going to be a web API. And let's just name this Dapper 101. So .NET created that scaffolded that application for me. Let's go into that newly created directory. And I'm going to use the .NET SDK. So I could use just simple HTTP or gRPC requests to the sidecar to talk to it and to call the Dapper APIs, and we will see us doing that later on in the session. But when I'm coding in C#, I prefer to use that .NET SDK because it makes it a little bit easier. It's basically a facade over all those HTTP requests, and it's just a little bit nice to work with. It also gives me some nice integration with ASP.NET Core, which I will show you in this demo. So now we've added that package reference. I can open up this folder in Visual Studio Code. And then to use that Dapper.NET SDK, I've just added a reference, but of course I also need to make some changes to my startup class to actually use it. So let's go to this services, configure services, and add both MVC as well as Dapper. Now this call to add Dapper does two things. So first, it registers some ASP.NET model binders So we can very easily work with the state management building block directly from our controllers, and it's really powerful, and I'll show you that in a bit. And then secondly, it registers a Dapper client class. Thank you for completing that Visual Studio Code. I need to add a using. So it registers an instance of Dapper client, or I should say it registers Dapper client with a dependency injection system of ASP.NET. And you can use this Dapper client to talk to the sidecar. So if you look at the kinds of methods that it exposes, it has some methods to work with state, such as delete bulk state. It has methods to work with secrets, get bulk secret. We will probably find some stuff around bindings to invoke them, to invoke method calls, or using service invocation, all kinds of stuff that you can call on the sidecar, all available from that single Dapper client facade. So with that registered, let's add some actual logic to this application. So we are going to create a banking application, and we need a controller for that. So I'm going to create a new controller and call this account controller. Then I'm not going to type a lot because I'll just make mistakes. So I'm using these snippets to save us all a lot of time. So this is my account controller. Now, first off, we need to know the name of the state store component that we want to use, because a single application can use multiple different state store components. So I've created a constant for that. You can see its value is state store, which is that default state store that you get for free when you run Dapr init. Now, our first method in this controller will allow us to get the, let's not scroll too far, to get the current balance. And it uses an HTTP GET, and that GET request should include the account number for which we want to know the balance. This method takes a single parameter, balance, of type int, and that's it's a very opinionated bank we've got here, by the way, because they only allow us to store balances with round numbers, but never mind that, this could be anything. The important thing here is I've decorated this parameter with this from state attribute, and that attribute is part of the Dapr SDK. And what it does is it automatically loads the state from the state store for me, and it puts it in this balance parameter. Now this requires two parameters. First off, the name of the store, which I pass using that constant. And then the second parameter is used to resolve the key to query the state store with. And because I've specified a count number here, Dapr will look inside the URL, look at the value which I've entered for account number, and it will use that value to query the store. And then I've got the current balance in that balance parameter, and then I only need to return that to the client. And I'm done with this method. Now, if there isn't a value for the given account yet, then we'll just get back the .NET default value for this type. And the default value for an integer type is 0. So that works out perfectly, because if you don't have an account with us, I want to return 0. Now, note that I'm talking about simple value types here, numbers, stuff like that, but you can use any .NET type here as long as it's JSON serializable. So this could be any complex type. Now let's have a look at this next method, which allows us to deposit some money in the account. Very important, of course. I'm using that from state attribute again. But instead of just int, I'm now using this state entry of int type. A state entry is a very useful type. It's basically a wrapper around my value that also allows me to update a value and save it back to the state store. So what happens here is that the balance now contains a value property, which contains the actual amount. So I add the given amount to that. And then I can call the save async method on the state entry to save that all back to the state store. And then again, I simply return the new balance to the user. Now the withdrawal method here is more of the same. The only change is that now, of course, we subtract the amount from the current balance instead of adding to it. Okay, let's see this in action, shall we? Now, normally, you would use .NET Run, right? Because this is just a .NET application, so you would use .NET Run to build it and to host it. But I also need to instantiate a Dapr Sidecar process because my application cannot run without that Dapr Sidecar. So to do that, I need to use Dapr Run. And then the first thing I need to do is I need to give this application an identifier. So let's call this bank. And I need to tell the Dapr Sidecar on which port my application will run, so that the sidecar is able to call into the application. Now, this is interesting because my .NET Web API will expose two ports, one for 5000, which is the HTTP port, and one for 5001, which is HTTPS. And the default template that I've created using .NET New Web API also includes middleware to redirect any incoming HTTP traffic on port 5000 to HTTP as endpoint on 5001. And that redirection breaks the communication between the Dapr Sidecar and my application. So there are two possible solutions for this. I could either just remove the middleware from my .NET application, which is, by the way, let me show you that really quick, which is this line here. So I could just remove that line, and then I can host my application port 5000. Or I can just go with HTTPS, but then I need to remember to explicitly tell the Dapr Sidecar that I want to use SSL. And you can do that by including that app SSL flag. So that's all the information that Dapr needs. Now I also need to instruct Dapr on how to run my application. And as we discussed, that's simply done by calling .NET Run. So now we see straight away a lot of logging. And the interesting thing here is that you can see two different types of logging. So first of all, there's a lot of logging coming from the Dapr Sidecar. And you can see it found those two components. Here it says, I'm going to load the components. Component loaded, name pubsub, type is pubsub. Component loaded, name is state, type state Redis. So it initialized everything. And then it's at a certain point, it started to run my application. So all this logging with the blue app in front of it, that's the log coming from my application. So it's very nice that you can see all the logging here together.
Sander,
yeah,
there was just a question in the chat, but maybe it's good to stress that this Redis that you see here, because it's using a Redis container, was also installed with Dapr in it.
Yeah. Yeah,
so people were asking, okay, where do these files come from? These component files, but it's all installed automatically with Dapr in it, including this Redis container, and it's running.
Yeah, exactly. So Dapr in it gives me these three containers. So it installs Redis, it installs Zipkin, and it installs the Dapr placement container. I think we may have somebody unmuted. So if you are unmuted, please mute your mic. All right, so our application is running, everything is running, this looks great. Let's scroll, make this a little bit smaller, and we are going to test our application. And I'm going to do that by adding a new file and naming this samples.http. And I've got a snippet for it somewhere. Yeah, here it is. Okay, so I'm using a Visual Studio Code extension called HTTP or called REST client, I should say. If you don't know it yet, it's a really great extension that allows you to write these HTTP requests and then invoke them. So it's really nice to test APIs. So let's say we want to get the current balance, and let's make this AzConf. Let's say that's the name of my account number. So if I send a request, I will just get back 0 because we haven't added anything to that account yet. So that makes sense. Let's start depositing some information in this AzConf account. So now we get back 19, 38, and so forth and so further. If I now request the balance, of course, it will give me back the same amount. So it's really stateful. And just to be complete, I will also show you that we can withdraw some money. Now, let me prove to you that it's really, really, really stateful. So I'm going to shut down this application, and then I'm going to try to get the balance again, which of course does not work because there's nothing listening on this port now that my application is shut down. So let me restart it again, and we should get back our previous balance now. And we do, 132. So now take a moment and think of all the things that we didn't have to do to make this work, right? We didn't need to add any specific SDKs or libraries for Redis. We didn't need to write any code to open and manage the connection to Redis. In fact, we didn't need any Redis skills at all. And we didn't really actually need to know there's Redis running underneath all of this. And on top of that, this application can now also really easily change from using Redis as its underlying data store to something else by just changing that component configuration file. So that's really interesting. So just to make one thing clear, there's a question in the chat about, hey, wasn't your application running on port 5001? Yes, it was, but it's also running on 5000 and it will just redirect me. So I could also make this an HTTP GET request to 5001, and that also works. That gives me the same result. So it's 5000 for HTTP, 5001 for HTTPS. That's the default port you get when you create a .NET application. I should update these samples because it's a little bit clearer if I use the HTTPS port here as well. All right, so going back to my slides, we've just seen us using Redis as a component, but there are a lot of different components already available to be plugged into Dapr. This slide's already a couple of months old now. The number of components have only increased since then. And of course, Dapr is completely open source. So if you miss anything, you can always create the implementation yourself and contribute it back to the community. That's always highly appreciated. All right, so a couple of questions left. From where will we get these samples? I don't have the code for the current sample, but it's really similar to a sample that's already in the Dapper repository. So we will provide you with some links at the end of the session. All the other samples that we are going to show, there's extensive code for that in GitHub. We will also give you those links at the end of the session. There's another question: what's needed to move from Redis from any other store? Because I'm a little bit teasing here. I've told you a couple of guys now. It's so easy to just move to a different store, and I'm not showing it to you how to do it. But we will. I'm saving that for when we talk more about the state management building block, and we go more in depth about what you can do with it, and also I will show you how we can change that Redis and move it over to Cosmos DB. So that's coming.
Yeah, but that's actually the $1 million question, and that's also where Dapper's strength is, because in this case it would only include a configuration change and no code changes. But like Sander said, we will dive into that later on.
Yeah, definitely. Okay, so yeah, but basically this is my quick Dapper 101. So what we are going to do now is Dapper, I'm calling you Dapper now, Edwin. Edwin will now introduce the demo app that we'll be using throughout the remainder of this workshop. Yes. And then after that introduction, you can choose if you want to keep watching us, going through all the exercises, ask us questions, stuff like that, or if you would rather want to do the exercise yourself. So yeah, over to you, Edwin.
Yes, I already started sharing my screen. I cannot see that, so please.
Yeah, I see your screen.
Okay,
yeah.
Awesome. Yeah, so the workshop case and sample application, that's what we're going to look at right now. And first dive into the case. So when we started creating a sample for learning Dapper, we wanted to have some domain, so to speak, that is very simple. We could, of course, take a bank or an insurance company or some other complex domain, but we wanted to keep it as simple as possible so we could focus on the Dapper components. So what we did was we've created a sample application that simulates this, and this is a stretch of highway somewhere in the Netherlands. I don't know people calling in from other countries, but this is something that we actually have in real life. So our government wants us to drive, don't want us to drive too fast. So what they do is they just take a stretch of highway without any on and off ramps, and they place entry cams at the beginning and exit cams at the end. So they're actually cameras above the road. And then when you drive beneath one of these cameras, it will take a picture, it will recognize your license plate, and then when you do the same at the end, another picture is taken, and then the system that is handling all these pictures can deduce from the time it took you from the entry to the exit cam how fast you were driving. And if that is above the speed limit for that stretch of highway, you will automatically get a ticket on your doormat. So that's basically what's happening here. And these are really annoying because you really have to stay within the speeding limits here. So if you overtake anyone and you drive a little bit faster, make sure that your average speed stays within the speeding limit.
They're not annoying. They're for the public good, Edwin.
Yeah, that's for the public.
You just want to drive too fast. That's the problem.
Yeah, I usually did, but I don't do anymore. So, and if you look at the bottom right, you actually see a picture of a sign that we see. So it's not sneaky or anything, which wouldn't be possible because there are huge camera arrays above the road. But that's an actual sign that says that one of these checks is coming up. So within this whole domain, we have two additional parties. So we have the system running this, and then we have the Department of Motor Vehicles. They have registrations on all the vehicles on the road, obviously, and their owner, which is important information for our government. And then we have the Central Fine Collection Agency. And this is the agency that actually gets all the speeding violations, and then they will get the information from the Department of Motor Vehicles on the vehicle and its owner, and then it will send you the speeding ticket. So, well, that's basically the domain that we're talking about. And what we did, we've built a small distributed application or microservices application to simulate this. And these are the parts that are in this system. So first of all, we have a camera simulation. And this is just a console application that will simulate cars driving under the entry and exit cams. And how does it simulate this? Well, there's a traffic control service that basically handles all the camera stuff. And this service has an entry cam and an exit cam endpoint. And this is just a REST service that I can send messages to. So the camera simulation will send messages with a vehicle's license plate to the entry cam and the exit cam endpoint. So that's what's going on here. Then the traffic control service will basically get this information, store the information when the car comes in and when the car goes out of this stretch of highway, and then calculate the average speed. If it then detects a speeding violation, it will send this speeding violation to the fine collection service. The fine collection service has a collect fine endpoint, so it sends the message there, and then the fine collection service is triggered to go and send a ticket. The fine collection service will then call into the vehicle registration service with the license number of the vehicle, and it will get the information of this vehicle and of its owner. And for this example application, we have used email as our way of sending the tickets. So the information only contains the email address of the owner and not its actual home address, for instance. So it's a little bit a simplified version of the real world. But yeah, for our demo, that worked great. So once this fine collection service has the information on the vehicle and the email address of the owner, it will then send a ticket to this email address. So this is how that works. All these services, so the traffic control service, fine collection service, and vehicle registration service are just ASP.NET Core Web API projects. So it's just RESTful services that you can talk to over HTTP. And the camera simulation is just a console application that sends messages. And starting out, we will start with this application completely running with HTTP. So we're just sending HTTP JSON payloads between these services. And then throughout the workshop, we will start Dapperizing this application. So we will be adding Dapper building blocks to these services and then replacing the HTTP communication with different means of communication. And what does this look like? So first of all, what we're going to do is, if we look at the end solution for the workshop, then all these services, so the traffic control, fine collection, and vehicle registration service will start running with a Dapper sidecar. So they will be Dapperized, so to speak. And then we will introduce all the building blocks. And the first one we're going to introduce is service invocation. And we're going to use service invocation between the fine collection service and the vehicle registration service. So instead of just sending an HTTP request from the one service to the other, we're going to call it through the Dapper sidecar user service invocation. And there's an entire module, and Sander's going to show you that, how that works, and then the application will be authored. The second building block we're going to use is pubs up. And this is going to be used between the traffic control service and the fine collection service. So once the traffic control service has detected a speeding violation, it will publish a speeding violation message to a message broker. In this case, we're going to use RabbitMQ. And bear with me, we're going to show a lot of infrastructural components in this picture, but we're going through it step by step, how to install them, how to run them. And we're going to use Docker extensively because this will be running with Docker. But we will provide you with instructions, both in the hands-on as in the live coding sessions, on how to do this. So the traffic control service will publish this through Dapr, and then it will be sent to a RabbitMQ broker. And the fine collection service will subscribe to these messages, and then the Dapr sidecar will send the message to the collect fine endpoint. So that's where we're going to use pubs up. The third building block we're going to use is state management. So in the initial version of the traffic control service, all the information of the vehicles is stored in memory. But this is, of course, a little bit dangerous, because if the traffic control service crashes or needs to go down for an update, for instance, then you lose all this information. So to make this a little bit more robust, we will use state management building block to store the state in a Redis cache in this case. The fourth building block we're going to use is an output binding. And we'll use the SMTP binding for sending the actual email with the speeding ticket. The fifth building block we're going to use is the input binding. This is also called a trigger. There's a little bit, there's a synonym for input binding. And we're going to use the MQTT input binding. So instead of the camera simulation just sending HTTP messages directly to the traffic control service, it will send an MQTT message to an MQTT broker. In this case, we're going to use Mosquito. This is a very lightweight MQTT broker. And then the traffic control service will subscribe to the MQTT broker, and then we'll get the messages for the entry cam and exit cam endpoints. And then last but not least, from the fine collection service, we're going to use the secrets management building block for using secrets. And the secrets that we're going to use are the username password for logging on to the SMTP server. And there's a thing going on with an API key. And it's a little bit of a, yeah, it's not production code, but just to show you how you can use secrets in from Dapr. So, and then after all these modules, we will be ending up with an application that looks like this. So all the Dapr building blocks are used with the different infrastructural components. I don't know if there are any questions, Sander. Please, you can break in if there are any questions that you want me to answer. So let's look at the application at work. So I'm going to go over to my Visual Studio Code. And here you see the solution that if you are going to go hands-on, you're also going to use this solution. So this is an application, and you see the different services in here. So the fine collection service, the simulation, the traffic control service, and the vehicle registration service. And these services are just, yeah, very simple ASP.NET Core Web API applications. So people that have done .NET before, you will recognize them. And as Sander already said, if you start doing the hands-on workshop for yourself, you can also choose to do them in Java or in Python. So you will have different solutions then, but the functionality and all the services will be exactly the same. So to let you see how this works, I've started up a couple of consoles here. So I will show you how I can run this application. I have already started all the infrastructural components on my machine, so they're just running in a Docker container. So I have a RabbitMQ, I have the Redis server that is installed with Dapr automatically, and I have an SMTP server running on my machine. Like I said, we'll go into the details later on. And now what I can do, I'm now in the folder of the vehicle registration service, and now I can start running this service. And just as Sander showed you in the example that he did in the one-on-one part, I'm using Dapr run to run this application. This is the vehicle registration service, so I use that as my application ID. The application is running on port 6002. Like I said, there's a lot of port numbers in these examples because we don't want any port clashes. Then I'm specifying that my Dapper sidecar will run on port 3602 for HTTP traffic and on 60002 for gRPC traffic. And I'm specifying a specific components path. So when you install Dapper, there will be some default components, as Sander showed already, installed in your machine, but we are using specific components. And if we go back to the source code, you see this folder here, Dapper, and then /components. In this folder, there are several configuration files, Dapper configuration files that configure all these building blocks. We will go into them in more detail later on, but this is the folder that's being used, and then those configurations will be used. And then I have to specify the command for starting my application, which is .NET run, which Sander already showed. So when I do this, the application will start. Again, we will see all the Dapper logging intertwined with my application logging. So this is a little bit hard to read, this blue stuff, but this is my application logging. And now my service is up and running. I'm going to do the same for the find collection service. So it's the same thing, but the ports are different and it's another application ID. And now I am in the find collection service folder. So I'm just running a different .NET application with the same set of components. The same with the traffic control service. And now almost services are up and running on my machine. And now I can start the simulation. And this is not running with Dapper because it's just a .NET application sending MQTT messages. So I'm just going to say .NET run. And then it will start a simulation. We will simulate a stretch of highway with 3 lanes. So there are 3 cameras. Each lane has a separate camera. And now you see that it is simulating cars with random license numbers driving under the cameras. If I now look at the logging of the traffic control service, you see all kinds of loggings going on here. So I will highlight some stuff. And here you can see that we see entry detected, exit detected, and also already some speeding violations detected. So we see that the license number with DY13SG drove 6 kilometers an hour too fast on this stretch of highway. So these speeding violations should be sent to the find collection service. So let's look at this logging. And yes, here we go. So we see all these fines coming in to the find collection service. And also you can see that the find collection service also figured out who the owner of the vehicle is. So in this case, it's Dagmar Wiltsy. The vehicle is a Suzuki Vitara, and it sent the vehicle, or it sent the speeding tickets to this person. So that seems to work. And then in the vehicle registration service, we can see here the logging that the information for all kinds of traffic, all kinds of license numbers is being retrieved. So my application is working. Now, the cool thing is because we actually have an SMTP server running on the machine, I can send you the emails that are being sent. And just to show you that they're coming in, I will clear my inbox for now because I'm using development SMTP server that doesn't actually send out emails, but it will show the emails that was sent to it in this a virtual inbox, so to speak. And here you can see that these speeding violations are coming in. So if I open one, you see that this is Mr. or Mrs. Oma Gudri with a Mitsubishi Eclipse Cross. And well, there's a speeding ticket. And this one is a very fast one because it drove more than 40 kilometers an hour too fast. So it doesn't get a usual fine, but it has to be determined by the prosecutor. But here you can see all these speeding tickets coming in. So we're actually making money, Sander. This is really going great.
Awesome.
So I will stop the simulation for now. But this is to give you an idea of what the application looks like. And this is exactly what you're going to see when you start doing the workshop, or you're going to follow us during the live coding sessions. We're going to work with this application throughout the entire session. So, well, now the time has come to give you some introduction on the workshop itself. So like I said, you will start out with a working application. So this is a workshop that will give you already a working application at the start, but they're all communicating over RESTful HTTP APIs. And then throughout the workshop, you will be adding Dapper to this application.
Yeah, that's important to note, I think, Edwin, that we won't be adding new features to the application. So every time you've changed something to Dapper and you rerun the application and it still works, that's success, right? Because now it's still working, but it's using Dapper, so we usually can strip out some other code, make it easier. So that's exactly. A good thing to keep in mind.
Yes. So here are a couple of links, and we will also share these links in the chat. But the first thing you need to do if you want to go hands-on is open up the repository that's shown here first. So it's all up on GitHub. If you go to github.com/edwinvw/dapper-workshop, this is where the description of the workshop is. You don't need to clone this repository, but it is just, you can just follow the README, and then it's set up so that you can click through all the assignments. And I will go there right now to show you what's going on. So if you look at the workshop, you see the README here, and basically everything that I have told you just now is also in this description. So there's lots of text here that I will scroll through. Then there's a very important part. I cannot stress this enough, the prerequisites. Please carefully go through these instructions, because if you do one thing wrong, then probably you won't be able to start with the workshop. So you need to have all these prerequisites installed. And then once you go through this introduction, you can go to the assignment. And these assignments all have the same form. We will specify a goal that you need to reach for this assignment. Well, assignment 1 is basically getting the application to run on your machine without any Dapper. So that's the first assignment. And then once you go to the next assignment, so this is the first one that you're going to add Dapper, we will give you a small introduction of what we want to achieve with this assignment. And then you have the ability to go to the step-by-step instructions for the individual technologies. So if you want to do .NET, you go to this one, for Java and for Python. And these step-by-step instructions will really meticulously tell you about what you need to do, why we do certain things, and will help you with getting everything up and running. So this is quite elaborate. And then you can go to the next assignment. If you look at the, and that's also in the instructions, so these links are also in the instructions. For the source code, you will be going to another repository, one for C#, one for Java, or one for Python. And this will contain all the source code. So it will contain the initial application running with HTTP, and that will be your start point. And from then on, you can just follow the instructions. Again, make sure you have these prerequisites installed. What we see if we do these workshops, that, well, basically 8 out of 10 questions and issues that people run into are because the prerequisites are not installed correctly, or there's some kind of a issue with writes, or you have some kind of a weird VPN running or something like that. So sometimes we see a lot of issues with that. So please make sure that you install them correctly, and then you can follow the step-by-step instructions.
Yeah, and please read carefully, because when I did, Edwin wrote most of these exercises, or basically all the exercises, I should say. And when I first did the workshop, I also got blocked at a couple of points. But it was mostly due to me not reading the instructions very well. So sometimes you think, oh, I know what he means, and you'll just click ahead and go ahead. But really look at all the ports, look at all the commands really carefully, maybe so you don't get stuck.
Yeah, there's quite a lot of text, but please read it, because it's there for a reason. And once you get with if you have assignment 2, for instance, up and running, then you will probably also can just go forward to the other one. So we will provide the links in the chat. And then what you can do is you can now choose to say, okay, I really like these guys. I want to see them do the assignments online. So you can just follow us, then just stay in these Teams meetings, and we will show you how this works. And if you say, okay, I want to get hands-on, I want to do it this myself, then open up the repository, and then you can start coding. Obviously, if you go for the hands-on route, you don't need to be done when this session is over. So you can just keep working on it. It's up on GitHub. We will share our Twitter handles later on, so you can even, if you have some questions, you can contact us. And if you find anything that's wrong with the workshop, please enter an issue or even a PR in the repository, because it's just up on GitHub, so you can help with that. So let's share the link, Sander. I will do that in a moment, and then people can
if you can share the link, then there was another question in the chat that popped up that I want to address for a minute, which is about basically the level of abstraction that Dapper provides. So the question or maybe comment here is that certain features of Redis streams are not supported on .NET, as SDK does not support it. Other languages support it though, so it should be theoretically be able to use it with .NET and Dapper. Mm-hmm. So the thing is that Dapper, of course, introduces this level of abstraction because Dapper, if we stay with the Redis example and with state management example.
Sorry, I actually did a typo in the link. I'm so stupid. I thought I won't copy paste it. I will just type it, and you get to get.
Oh no! Always copy paste.
Yeah, I already fixed it. So.
Okay, so if you look at the state management, the Dapper provides that state management API on the Sidecar, and that's your API, and that defines what you can and you cannot do with Dapper state management. And then you've got all these components that plug into that and provide an implementation of that API. Now, some technologies may provide additional features that are not exposed by that API interface. So Redis streams is a great example. Redis or Dapper does not use Redis streams, so you cannot use Redis streams through the Dapper state management building block. What the team tries to do is to create an abstraction that is basically satisfactory in 80-90% of general cases. So that typically you can just use Dapper and have that, have the flexibility of just choosing an implementation and switching those implementations when you need something else. But then, of course, there are always situations where that abstraction is not good enough and you need more than what the Dapper interfaces provide. And in that case, I would say, go with it, just use that feature if it's really useful for your solution, but then you need to go around Dapper. So you could still use some of the Dapper building blocks. You could even use the state management building block for certain features of your application. And then for other features of your application, use Redis SDK directly or a Redis NuGet directly, and just mix and match. But that's always something to keep in mind. If we want to make things simpler, we need to abstract some of the stuff away. And if we make an abstraction, you always lose something. You cannot cater to all scenarios. So that is something to keep in mind.
Yeah, and I think that's also, I guess you already mentioned that, but I want to stress that that's the strength of Dapper. You don't need to use everything of Dapper without your entire application. It's just you cherry pick the stuff that you can use, and you don't use it when it's not, fit for the situation or it's not available within Dapper. So you can just mix and match everything.
Exactly.
Great question, by the way.
All right. So where are we at? So Edwin, can you also add the other links, or are the other links contained in the first one?
They are also in the. If you go to the, I will share them, but they're also in the description. So yes.
Okay. So basically, if you go to that first link, you will get all the information you need.
I will just share them just to be sure.
Okay. So while you're doing that, let me take your screen away from you.
Yes. Because you're going to talk about the first building block, right?
But before that, we still got this nice live coding slide.
Sure, yeah.
So these are the building blocks we're going to talk about. Lunch is a little bit delayed because I think we're running a little bit behind our schedule by 10-15 minutes at the most. So let's just delay lunch a little bit just so that we can get through service invocation and pops up before that. And then after lunch, we look at basically all the other building blocks There's still a break in there between input binding and sequence management. It might be good to let's just look at the time, and if we've got enough time for that. Otherwise, we'll just plow through. And if you want to get coffee or something in the meantime, remember this also being recorded. So if you miss a little part of the session, you can always watch it back later.
Yes.
Okay, let's start with the first actual building block section, which is about service invocation. And yes, we will also share this presentation, this entire slide deck, so you can look at it later. Okay, so across a distributed system, because we are talking about distributed systems, right? Microservice systems with a lot of moving parts. And these different parts, these different services often need to communicate directly with each other. So let's look at an example of a non-Dapperized application. You could use direct HTTP calls between the services, right? So let's say we have this Python app and we have a Node app, and the Python app makes a direct request to the Node app over HTTP. Now let's look at this URL for a little bit. Obviously, it needs to contain the IP address and port of the Node app in order to call it, right? You need to be able to know where that service is, otherwise you cannot call it. So that Python app needs that information. So these two are a little bit tightly coupled. Now let's look what changes in this picture if we introduce Dapper service invocation. Instead of directly calling the remote service, the Python app will now call its local Dapper sidecar. So that HTTP request is now going to localhost. So the Python app does not need to know where the Node app is located. It only needs to know where its own sidecar is located. That's basically always on the same host. So it's localhost 3500 in this example is the default port for the Dapper sidecar. And then you can see we are invoking or we are calling, I should say, the invoke endpoint of the Dapper API, and we give that the app ID of the app we want to call, which is Node app, and then we also give it the method name or the route that we want to call on that remote service. So now that call is received by our Dapper sidecar, and that sidecar will perform service discovery for us. So if you're running in self-hosted mode like we are, then Dapper uses a multicast DNS for service discovery. But if you run this in Kubernetes, it's going to be a little bit different. Then Dapper will automatically use the Kubernetes naming service. That's also transparent for you. It's nothing to be worried about or having to configure. Dapper just does that for you. And as of Dapper 1.2, you can also configure Dapper manually to use HashiCorp console for naming servers. And that's great because that provides a whole new list of scenarios of where you can run Dapper. Basically, using any of these methods, Dapper will now know where the remote service is located, and then it can forward a call to that remote Dapper instance using a gRPC. So this call between sidecars is always in done using gRPC. And then finally, that remote sidecar will now call the remote application. So it will call the Node app, give it the payload, and any result will then flow back to the original caller. So why would we go through all of this hassle just to make a simple service call? Because from the looks of it, I need a lot more boxes and lines and arrows to make this clear. So this is obviously a little bit more complicated than just directly calling the Node app. Well, there are a couple of really nice benefits that Dapper can provide now that the traffic flows through these sidecars here. So first of all, the services are much more loosely coupled now because they don't need to know each other's addresses anymore. If a service call fails, then Dapper can now automatically on your behalf do some retries for you. So you don't need to do that inside your application anymore. Service calls are now also automatically secured because Dapper uses MTLS to encrypt the traffic between the services, and Dapper also takes care of creating the certificates for that and do automatic rollovers and stuff like that. And finally, this is really great for observability because all of these calls can now automatically be traced, which Edwin will demonstrate later on. All right, so going back to this traffic control diagram that Edwin introduced, my next demo will focus on the communication between the fine collection servers and the vehicle registration servers. So whenever the fine collection service registers a fine, it needs to get some vehicle details from this vehicle registration service. And at the start of the demo, that is still implemented as a direct HTTP call. And we'll change that HTTP call to Dapper service invocation so that the end result will be as shown in this diagram here. All right, demo time. Let me switch to my Visual Studio Code and let's start by looking at the vehicle registration service. So this is the service that we want to call. And this service contains a vehicle info controller. Let me close my terminal to make a little bit more room here. So this is just an ordinary ASP.NET Core controller. It contains a single endpoint, which is called getVehicleInfo. And when this endpoint is called, the given license number is used to look up the vehicle info in a repository. Now that repository is a really simple implementation. It just creates a random some random vehicle details based on that license number. And then we simply return that information to the client. Now, because we want to call this service using Dapper, it needs a Dapper sidecar. So we need to run this service using Dapper run. So I've got these 4 terminal windows open here. The traffic service is already running. That is not Dapper enabled yet, so I've just started it with .NET Run. And now the vehicle service, I want to start using Dapper. So I should be able to do it like this. Yeah. So what I'm running here is Dapper Run. I'm using the app ID vehicle registration service. Then I need to set all the ports for the communication between the app and the sidecar. And then I simply call .NET Run. So now that service is running along with its sidecar. Now, as you might notice, we didn't need to change any code for this to work. Vehicle registration is still just a web API listening for requests. Only now other services can call this service through its Dapper sidecar. So let's move over to the other part of this equation, which is the find collection service. And this is the service that is going to call the vehicle registration service. And to do that, we've got this proxy folder here, which contains a vehicle registration service. So this is a proxy class that is used to call the actual vehicle registration service. It's also pretty simple. We just used this HTTP client, which gets injected into the constructor. And we use that to get the JSON from that vehicle info endpoint. Now, without Dapper, we needed to know where the vehicle registration service is running. But when we use Dapper, we only need to know where our local sidecar is running. So we can change this URL here, which was the original location of the vehicle registration info, to a call to our local sidecar. So this new URL is a little bit longer. Let me close the sidebar for that. So we are making this a call to a local host. 3601 is the listening port of the find collection service sidecar, so of my local sidecar. And then in the URL, we indicate that we want to call the vehicle registration service. And vehicle info / license number is the method or the route that we want to call on that service. So let's see if this works. Let's go to the find collection service window. And let's also do a Dapper run. This time it's for the find collection service, different ports for that service, and we simply want to do .NET Run. So now we've got all the 3 services up and running. We can go to the simulation and we can start a simulation. So the simulation itself does not use Dapper, so we can simply start it using .NET Run. it will start simulating stuff. And if we go over to define collection servers, we already see some speeding tickets coming in. So it's already sending fines, and in order to do that, it of course needed to call the vehicle registration service for some details, and we can also see that working as well. So without changing any code, just running our applications using Dapper and changing that URL to go to the local sidecar instead of the service directly, we are now routing the traffic through the Dapper sidecars. And we get all those Dapper benefits. So for example, if I was to run this in Kubernetes, then all the traffic would already be automatically encrypted for me. So that's pretty nice. Now let's stop this simulation and also stop the find collection search, because we will change the implementation a bit further. Let's go back to that proxy class, because it's nice that we just needed to change this URL and it works, but I don't really like this URL. It's a bit messy, having such a long URL in the code. So maybe we can keep these URLs closer to the original URLs, and there's a way to do that. But in order to show you that, first let me just rewrite this one-liner into this other piece of code, which is functionally the same, only it's a little bit different written up. So now I explicitly create a request message. I give it that exact same URL. I send it using the HTTP client, and I get back the result. So functionally exactly the same. But the reason that I've changed this code is that now we can add HTTP headers to the request. So I can let Dapper know which service to call by including a Dapper app ID header. And when I do that, I can remove this entire part from the URL, because it will use the HTTP header to figure out what service to call. So we still need to target our sidecar, of course, so the URL still is going to localhost 3601, but now the route hasn't changed from the original URL. And that is a good option if you want to keep those routes the same if you're Dapperizing an existing code base. So these are all examples where we use the regular HTTP client to make HTTP calls. And I'm using C#, of course, but you can make these calls from any platform. But now let's change this even further, and let's add some .NET specific functionality by adding the Dapper.NET SDK. So first off, we will need to add the NuGet package for the SDK again, just like I did in my first demo. So I'm going to call .NET add a package, and it's called Dapper ASP.NET Core. Already ready. And then let's go to our method, and let's change that to this new implementation, which uses the SDK. So this is even better. Now we've got this nice short URL. You can see in this case, now we can use the application ID as the host name. And the route is still the same as the original URL. And we don't need to send any custom headers. So how does this work? Well, the SDK contains a special HTTP client message handler that can rewrite the URIs of outgoing requests. So that specialized message handler will take this URL that we put in, and it will automatically rewrite it to that longer form that we used earlier. So in fact, if we configure this HTTP client to have this app ID as its base address, then in this class, we can even shorten it to just the route. And I really like that, because now we're at a point where if you look at this class, you cannot even see that we are using Dapper to make the service call. We just use HTTP client in a way that we're used to. Now, of course, this is not the complete story yet. We still need to make sure that this HTTP client is the special Dapper HTTP client instead of the good old .NET regular client. So we'll need to make some changes to the startup class. I see there's a question in the chat about how will you manage API versioning. That's basically still up to you, because what Dapper provides here is a way to call remote servers, and I can still decide for myself if I want to. Okay. So the question is more that with long URL we were passing API version 1.0. So that's an interesting question, by the way, because so this URL will be rewritten to something like this: localhost blah 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 sidecar /v1.0/invoke/serve stem yada yada. So the question is about this 1.0 here. If you remove that, how the hell does Dapper know which version to use? Well, I believe that's the version of the Dapper API. So the .NET SDK, the version of the .NET SDK, will determine what version of the Dapper API it will use. So it's basically something you don't really have to care about, as long as you make sure that the version of the Dapper.NET SDK that you use is aligned with the version of the Dapper Sidecar that you use. Okay, so let's make this work. Let's go to the startup.cs and let's see where we actually registered that service. Oh, we did it over here. So here you can see we added the good old HTTP client and we added a singleton for the vehicle registration servers. So let's rip those out and let's change those with this new snippet. So now I'm adding the vehicle registration service proxy as a singleton. And with that registration, I also provide this factory lambda function. And when that function is called to create the singleton instance, I first use this Dapper client, which I need to add a using statement for, otherwise it doesn't recognize the namespace. I use the Dapper client to call create invoke HTTP client, and that gives me that special Dapper HTTP client. Now this method takes two parameters. So the first one is the name of the service that I want this HTTP client to call. And then the second one is the location of the Dapper sidecar. And again, if you're using a container orchestrator such as Kubernetes, you can use default values for this. So you don't need to specify it explicitly. But because we're on this single machine with all the different port numbers, I have to give them each separate port numbers.
And Sander, you said you specified the name of the service, but to stress this is the application ID that the service is running with.
Yes,
level,
exactly.
Right?
So the vehicle registration service, I started that with the flag app ID is vehicle registration servers. And that's the value that I'm referring to here. Yeah, exactly. Okay, so once I've got that HTTP client, I can create the instance of my proxy object, and I can return that. So with this setup, everything should be working. So let's restart this file collection service. Bada bim, bada boom. And also restart the simulation. And if everything is successful, we shouldn't see any errors and things. We should just see the same result of the file collection service. Registering fines, and here's the first one, setting a speeding tick to Major Dorard. You've got some strange names in there, Edwin. And then we can go to the vehicle, and again we can still see this being called successfully by the file collection servers. So yeah, this runs absolutely great with the Dapper.NET SDK. And we'll be using the .NET SDK for all the other demos that follow as well. So that's the demo for service invocation. To wrap this up quickly, it's really nice that the Dapper.NET SDK works so well with the HTTP client class, because HTTP client is such a well-known class that many devs already use in their code. So it allows you to reuse your existing skills. Of course, HTTP client already supports many advanced scenarios, and it integrates really nice with other frameworks such as Refit and Poly. So that's great. Are there any questions left in the chat, Edwin, that we should address now?
Yeah, that was a great question about, okay, this is running locally, but what when I run in Kubernetes? Are there any changes? And that's the cool thing. There aren't any changes there. So
no, there aren't any changes. So the one thing I would think would change is probably this part, right? Because your sidecar port may be different in Kubernetes, but that's something that you can really easily solve just by including a configuration setting for your application that contains the port of the sidecar, and then read that from configuration and put it in here. As far as as your code is concerned, there aren't any changes needed to run this in Kubernetes. All right, so seeing the implementation so far, I wonder why should Dapr run as a sidecar? It could very well be deployed another microservice. Yeah, that's right. So the important thing here is that you've got these, it's exposed as an HTTP API, right? So it's not running inside your own process. And that gives you the flexibility of using all those different languages and platforms. Now,
yeah, basically your sidecar is a small microservice running alongside your service, basically.
Exactly. And the reason we call it a sidecar, or we make it more explicitly that than a separate service, is that you generally want those calls to Dapr to be really quick, and you don't want them to incur a lot of network latency. So if you're running it as a sidecar, then the application and sidecar containers are running on the same host. So those calls will still be local. But you can indeed, and I've seen some cool demos for that, you could just create a single instance of a Dapr container. So you've got a single Dapr instance, and then let different microservices that you write use only that single Dapr instance. That is possible for some fun scenarios, but you will get into problems really quickly if you try to build a real system that way, because in a real world system, you will probably want to specify different settings and different security settings for each sidecar to specifically specify what it's allowed and not allowed to do. And it's much easier to do that if you just give every microservice its own sidecar. All right, so we should be stopping for lunch now, but I think it would be better if right now we first do pub subscribe.
Yeah, and then do lunch.
So let me give it back to you, Edwin,
yes.
for the pub sub section.
Okay, so let me get my setup back. Yes, there's the chat, and as I'm sharing my screen right now. So pub sub. The publish subscribe building block is for doing the pub sub thing. Pub sub is also, of course, a concept or a pattern that we know. And it basically means that you want to send messages without needing to know which consumers you have, or even if there are consumers and how many there are. So you just want to post a message somewhere, and you want other services to be able to subscribe to those messages without them knowing each other. So that's where pub sub comes in. So this is a general pattern that has been implemented by the pub sub building block in Dapr, and this is how that works. So we have an example here. We have another microservice. In this case, it's the cart service, and it has its Dapr sidecar running alongside of it. And when it wants to publish a message, it will call the Dapr sidecar on a certain API. And we just saw Sander use the invoke API for service invocation. In this case, I'm using localhost 3500, which is the port the Dapr sidecar is running on, v1, and then publish. So this is a different API that I call on the Dapr sidecar, and I have to specify some things. So first of all, I have to specify what the name of the pub sub component is I want to use, and what the topic is I want to send the message to. And those are two very important parts of information, because the pub sub component name will specify the configuration that I'm going to use. So I'm using the pub sub building block, but I can even have, for instance, multiple pub/sub components within my application. I could send certain messages to RabbitMQ and other messages to Kafka, for instance, if you want to do that. So you have to specify which pub/sub component you want to use, and you can specify the name here. And then orders is the topic, and the topic is, yeah, you could call it like your mailbox. So there's a named mailbox that you can send the messages to, and then other services can subscribe to these topics. So that's important to specify. A little bit confusing here is the name pub/sub, because we could name it anything we want, foo or bar or mycool component, whatever. But in the examples, it is called pub/sub. So don't let that fool you. So you can use any name that you want. If I call this API call using pub/sub and orders, I will send the message to the message broker that was configured with that pub/sub component. So in this case, I'm using Redis, but you see another couple of message brokers here, so Nets or Azure Service Bus or RabbitMQ. That's all based on configuration. So my code will not change if I want to send it to a different message broker. Once the message has been sent to the message broker, on the subscribe side, services can subscribe to this same broker using Dapr. So here you can, for instance, see that there are two services that subscribe. So there's a shipping service and a billing service on the right, and they both subscribe through the Dapr sidecar to this topic, in this case, the orders topic. And every time a message comes into this orders topic, each of these services will get a copy of the message, and the Dapr sidecar will handle that for you. And then the Dapr sidecar will call a certain endpoint on your application. And this is really important to grasp because you have to specify that. So when the Dapr sidecar, or for instance, the shipping service in this case, starts, it will call the shipping service to say, okay, which subscriptions do you want on the broker? Then you have to specify that, and I will show you in a minute how that works. It's pretty easy, actually. Barely an inconvenience. And then you specify that in case of the shipping service, you want to call /order, but in case of the billing service, you want to call /order processing. So you specify which endpoint on your HTTP endpoint you want to be called when the message comes into the orders topic. So this is how that works. Now I'm going to show you how that works within the Dapr traffic control context, and this is what we're looking at. So the traffic control service, once it has detected a speeding violation, it will send this speeding violation message to a RabbitMQ broker, and the find collection service will subscribe to this RabbitMQ broker on a certain topic, and then it will link this to the collect find endpoint. So this is what we're going to build right now. So let's go over to Visual Studio Code and make this happen. Again, you see my solution here. These are the services again. And what we're going to do now is, first of all, we're going to take care of the publishing side of things. So the traffic control service is going to send messages to the find collection service. So this is the first thing we're going to do. Before I'm going to do that, I first want to show you that I'm going to run an actual RabbitMQ on my machine as a Docker container, so I can use that as my broker. So I will start RabbitMQ. I'm using Docker Desktop, which is installed on my machine, and I'm running Docker RabbitMQ here. I'm using the name DTC RabbitMQ, and I'm using the RabbitMQ image just that's up on Docker Hub. So this is just a general RabbitMQ image that's out there. And I'm exposing a couple of ports so that I can access this from my local machine. So I will start this, and now the container is running. So I now have a RabbitMQ on my machine, and I can do this, Docker logs, DTC RabbitMQ. And here you see that my RabbitMQ has started, and it's all good. So now I can use that as the broker for my solution. So that's the first step. So now let's dive in and start configuring a Dapr component, or a Dapr building block, basically. So it uses this RabbitMQ broker. So what I'm going to do is, in my solution, that's within the Dapr traffic control solution, I'm going to create a new folder, and I'm calling that Dapr. And then within that folder, I'm going to make a components folder. So this Dapr components folder will contain all the component configuration files that we're going to use. Now, first of all, what I'm going to do is I'm going to go into this Dapr components folder, and I'm going to copy the components from my profile. So if I install Dapr on my machine, Dapr will automatically install a state management and a pub/sub component that uses Redis by default onto my machine, and they live in this folder, so in my user profile /dapr/components. And I will copy these files into my, let's go back to the vehicle registration service. And now I have copied these files into this folder. And if I go to state store, this is the one that Sander already showed. You can see that it is using the Redis server on my machine on localhost. And if I go into the pub/sub component, this also uses this Redis service by default. So this is the one we're going to change, because now we don't want to use Redis anymore. We want to use RabbitMQ. So I'm going to change this configuration, and I'm going to paste in this configuration file. So here you can see we're configuring a component. It is the pub/sub is the name of the component. So again, don't get fooled by this name. I could have named this anything, but we wanted to stay as close to the examples as possible. I'm using RabbitMQ now, so it is a pub/sub type building block, and I'm using the RabbitMQ as the broker. And then I have some metadata that is specific for this broker. So in this case, you see that I'm connecting to localhost 572. I don't want durable queues, etc., etc. We won't go through all these settings, but these settings will also differ per broker. So if I would be using, for instance, Azure Service Bus, I would have different things here in this metadata. There's probably a connection string and some credentials and stuff like that. So that could be different per broker. And then there's an important thing that we use a lot within Dapr, and that is called scopes. Because if I would use this configuration file, then every service that I start, that I point to this components folder to use, it would be able to access this broker. And I don't want that. I only want the traffic control service and the fine collection service to be able to use this. And again, these are the app IDs that I use for running the services. So these are the only services that can access that. So now I have changed the configuration. And what I can do now is I can start sending messages from the traffic control service to the fine collection service. So what I'm going to do, I'm going to go into the folder of the traffic control service. And first of all, what I need to do, I have to add a Dapper package, because I want to use the .NET SDK for Dapper for doing these calls. So what I do is .NET add package dapper.ASP.NET Core, and then it will automatically add this service to my or this NuGet package to my project file. Here it is. So you see that it added the 1.4.0 version of this package. So that's the first thing I need to do. And now I am able to use the Dapper SDK for .NET for my code. Now I'm going to go into the controller, and I'm going to go into the traffic controller, and I'm going to find the place in the code where the actual speeding violation is sent. And actually, that is when we get a vehicle exit message. So when a vehicle exits, we see a couple of things going on. First of all, we're going to get and update the state in our state management, just as Sander showed in the demo before. Then we're going to specify, or we're going to calculate whether or not there was a speeding violation. And if the speeding violation is detected, then we do a couple of things. So first of all, we log that there's a speeding violation. We create a speeding violation message, and it contains the license number, the road where we detected the speeding violation, how much the speeding violation is in kilometers an hour, and the timestamp that the speeding violation was detected. And then here you see where we sent, in this case, an HTTP message directly to our collect fine. So I know that on localhost 6001, that is where my fine collection service runs. I need to know that because I actually send it directly to the service, and I know that I need to call the collect fine endpoint. So this is what we're going to change. So I'm going to remove this code, and I'm going to replace it with this. So I'm going to use the Dapper client, which is part of the SDK for .NET, and I'm going to say publish event async. I specify the name of the pub/sub component I want to use. So again, this is pub/sub, and that corresponds to the name that I have configured. I have to specify the topic I want to send the message to, and I specify the message. And as you see here, I don't need to make JSON or whatever from this message. I just give it the object, and the Dapper client will take care of that. So it will automatically serialize this to JSON. And actually, another thing happens that I will go into a little bit later when we look at the receiving part, because it will also wrap this message in a cloud events message, which is a standard way of formatting JSON messages. So we have to take that into consideration. But this is all I need to do to start publishing messages to my broker, in this case, RabbitMQ. Well, you see some squigglies here. So what I need to do is I have to make sure that this Dapper client is known here. And there's a cool trick within .NET that you can do. What I can say here is I can say from services, and then I say Dapper client, which is the type I need, and the name is Dapper client. And I need to add a using statement, so this type is known using Dapper client, and now this type is known within the scope of this this method. So now I can use it. All the squigglies are gone. There's one thing I need to do still, because in order for this service to be, or this client to be injected by dependency injection, this is a standard method within .NET, I have to register it in my startup. So here you can see I already add the HTTP client. We basically don't need that anymore, but just leave it in there. But I will add something here, and this is how I do that. So I just say within configure services, services.add Dapper client. And then with this builder, Lambda, I can say, I want to use specific ports. Again, we don't want these port collisions on local machine. So we're specifying the ports where the Dapper Sidecar needs to run, or where the Dapper Sidecar basically runs. So now it knows that my Sidecar runs on 3600 and 60,000 for gRPC. And that's all there is to it. So now when I start this service, the Dapper client with the correct configuration is injected. And then when an exit is detected and there's a speeding violation, it will publish a message to RabbitMQ. So that's the sending part of the equation done. So now let's go over to the other service, and we go over to the find collection service, which is the recipient. So first what we need to do is, like I said, we will make sure that we specify which endpoint we want to be called when a message comes in to the speeding violations topic that we used on the sending side. So if we go into the collection controller within this service and we go to the collect find method, so this is the HTTP method that is living on route collect find, that is the one I want to be called when a message comes in. And within the .NET SDK, it's really easy to do that, because what I can do now is I can go here and I can add an attribute to it. And this attribute comes from the Dapper SDK, which I already used within this service. So I can just say, decorate this method with the topic speeding violations and use the pub/sub component named pub/sub. And this will create a link between this topic through this pub/sub component and this HTTP method automatically. And like I said, Dapper has a way of asking you which endpoints you want to be called. So this is what I need to do to create this link. But there's two more things I need to do. So once I have done that, I have to go into the startup. And the first thing I have to do is I go into the configure method in my startup class, and I'm adding this line. And as I said before, when I send the message, Dapper will automatically wrap my payload in a cloud events envelope, so to speak. And in order to get the message or the payload from the event, I have to unwrap it from the cloud events wrapper. And this is how I do that. So in ASP.NET Core, what this service was built with, there's a request pipeline, and this will inject a part into this pipeline that will automatically unwrap the message for me. And then the payload will automatically be delivered, and in this case, it's just a speeding violation object, because through model binding that is automatically done by ASP.NET Core MVC, this method of this object will be deserialized from the JSON. But this line, I need this in order to unwrap the payload from the Cloud Events wrapper. So that is one thing I need to do. And then the last thing I need to do, because I have decorated this method with an attribute, I still have to specify to Dapper which endpoints I want to be able to, which endpoints I want to be called when messages come into a certain endpoint. And for this, I can add this line. So Dapr adds a map subscribe handler method that I can use, and this will automatically, basically implement an additional endpoint on my service that Dapr can call, and then through this endpoint, it will get the information on the endpoint it needs to call when a message comes in. So this is all I need to do. So what I can do now, everything is already saved. I will go back to my console, and we'll start all the services again in reverse order. So first of all, I'm going to start the vehicle registration service. This hasn't changed, so this will just start as before. I'm going into the find collection service, also start this. And what you can see here again is that I specify this components folder that I just added. So Dapr components, this is the folder that I use. So it will use the component configuration files in this folder. Going to run this also. And what you see here is also information from Dapr. Here you see that the application is subscribed to the following topics: speeding violations, true pops up, named pops up. So you see that actually this service is now registered to messages coming into the speeding violations endpoint or topic on the RabbitMQ. Now I'm going to start the traffic control service, which is the sender. Like that, and then I'm going to start the simulation. And then the simulation starts running. So what we should see now is that when a speeding violation comes in and the traffic control service sends this to the find collection service, let's first check if this works. So I already see some speeding violations coming in. Let's go to the find collection service, and here we go. So you see that it still works. So we see that the speeding violations are sent to the find collection service. So everything works great. But now an additional thing that we can do, if we now log into the RabbitMQ management console on my local machine, and I go into the exchanges, I can actually see that a speeding violations exchange was created by Dapr because I send messages there. And the speeding violations exchange actually gets messages now. So we see that the speeding violations are actually running through RabbitMQ. And I can also see that there's a find collection service -speeding violations queue that was bound to this exchange. So this is my subscription side. And if I go to that queue, you can actually see that messages are flowing into the service. And the really cool thing is now, if I, for instance, go to the find collection service and I stop this service for a while, then actually you can see these messages piling up in RabbitMQ. So if we go here and we wait a little bit for a refresh, then we will actually see messages going in to the queue because the simulation is still running. Yeah, there we go. So now you see that messages are not picked up immediately, but they are just filling up the queue. And if I now restart this find collection service again, then you will see that messages get picked up again and that the queue will be read and will be emptied. So with that, that's publish subscribe. I haven't watched the chat, so I saw that a lot of questions were already answered by you, Sander. Are there still any questions?
Yeah. So we're still not completely done with with questions yet. We were talking about the sidecar having to call back into your application, and of course you need to expose an endpoint on your application for that. Yes. So what are some of the security considerations around that? Because you don't want any external client to be able to attack your application. You want to keep your attack surface as small as possible. So one thing I linked to in the chat is the feature of the app API token, where you specify a token on the Dapr Sidecar, and the Dapr Sidecar will send that token along with any request to your application, and then your application can validate it. Yeah. Now, of course, that doesn't protect you from external clients making up tokens and just trying to DDoS you. Yeah. But I actually think that that's not really a Dapr specific concern, because every time you want to expose some functionality to the outside world, you are going to deal with that. So yes, if you want to use Dapper for PubSub, you will need to expose that endpoint on your local host, right? Because the sidecar is running on the same node as your application.
Yeah, exactly.
So that doesn't mean that you immediately need to expose that endpoint to the outside world. And if you look at a realistic production scenario, then there can be all kinds of things in the middle with API gateways and load balancers and firewalls and stuff that can also help you protect your application from bad outside actors.
Yeah, exactly. So basically this endpoint for getting the subscriptions should only be accessible from the Dapper sidecar and not from outside your pod or outside your machine. That's totally correct. There was another question, or maybe first of all, let me show there's also an alternative way of specifying these subscriptions. So what I did now was I specified this endpoint, right? So this is the additional endpoint that I specified that gives you the information. But I could also do it declaratively. So there's another way of doing this. So what I could have done is in my components folder, I could also create a subscription and then specify it like this. So the Dapper, when the Dapper sidecar starts, it will get this configuration file. And then I say, okay, the topic speeding violations with PubSub name PubSub. I wanted to call the /collect find endpoint, and then I scope that to the find collection service. So this is the exact same way. And then I could even remove the attribute from my code, and I could remove also this endpoint. So I won't be offering this endpoint anymore to the outside world. And I could also remove this this topic attribute, because this subscription says it all. It gives you the PubSub name, the route, and the topic. So this is an alternative way. And there was another question that, okay, this is quite hard without the .NET SDK. Well, it's not really hard, because you could just, of course, create this endpoint on your local service. So Dapper /subscribe. This is the actual method that is called by the Dapper sidecar. And as you can see here, the data that you need to supply is really simple. So you have to just say, okay, this is the PubSub name, this is the topic, and this is the route that I want to be called. And then there's another cool feature that was introduced later, because this is also something that you can specify. This was added later on, is that if you don't want this cloud events thing, because you could be a service that doesn't have cloud events because you're not Dapperized from the start on, then you can say raw payload is true, and then it will not be wrapped in the cloud events wrapper. So that's also something if you want to, for instance, integrate with existing services that don't use Dapper but just read messages from the sidecar or from the broker. Right? Does that answer the question?
I hope everybody here has had a good refresh break. Let me switch over to my screen again, and we'll continue our workshop and look at the state management building block. All right, so I've of course already showed you a quick demo of state management in the beginning. In this part, we'll elaborate a bit on that. But first, I want to do a quick theoretical recap of what the state management building block does. So state management allows you to save these key value pairs in a pluggable state store. And what's really important to know is that it's really meant for storing transactional or hot state. So let's say the contents of a shopping basket, that would be a good fit, or the state of an ordering process, something that is easily, how do you call it, modeled with key value pairs. So it's not designed to be a complete replacement for your relational database. So don't use it to store your entire registration of all your customers and all the history and stuff like that. Just use a regular relational database for that, something like a SQL Server or MySQL. This is really useful for those instances where you have some part of hot state and you simply want it to be persistent. So how does it work? Well, of course, we've got our application, and then we've got our Dapper sidecar. I think somebody is unmuted. Can you make sure they're muted, Edwin? And then the application, if it wants to store some state, of course, we simply make a simple call to the Dapr sidecar. Now that URL includes the name of the state store that we want to use. And in the request message, you can see the key value pairs that we want to store. And those values can be simple. So for example, here the key is weapon and the value is dead star, which is just a simple string, or it can be more complex. So in this simple key is planet and the value is a JSON document, which itself has a name property set to Tatooine. So you can store any JSON in the values. Now, don't store a gigabyte of JSON in the value because that will hurt performance. So keep them kind of small. Okay, so that request is going to the Dapr sidecar. Then Dapr will look at its configuration, find the component to use, and then use that component to store the state. And then, of course, we can also retrieve our state by making another call to the sidecar. In this case, a get request. We again include the store name, but we also give the name of the state or the key of the state that we want to query. And then Dapr again will use that component to query for the state, and it will return that in the HTTP response. So pretty simple. There's some more advanced stuff you can do. For example, you can use transactions to make bulk updates. Not every state store support that. So if you look at the Dapr documentation, there's a list of state stores that do support it. But for now, we'll just focus on the basics. Okay, so let's look at our architecture diagram again. This demo will focus on the traffic control servers. So at the start of the lab, the traffic control server simply keeps the vehicle state in memory. There's no persistence at all going on. And it's our job to fix this and to make sure that our vehicle state is safely persisted. So let's go back to Visual Studio Code. And first we'll have a look at the traffic control server. So let me open that up. And let's look at that traffic controller class again. Let's go scroll a little bit up to the constructor. So we've got our traffic controller, which is our ASP.NET controller. And you can see this iVehicle state repository instance being injected in the constructor. And then in the vehicle entry method, we use that repository to save the vehicle state. And then in the exit method, so this happens when a car leaves the trajectory, then we use that repository to reload our state, make some changes, and then save it back again. So let's look at how that repository is implemented. Its current implementation is in this in-memory vehicle state repository class. So that name kind of gives it away, that it's not really persistent, but we use this concurrent dictionary here to save the state directly in memory. So right now, if you run this application, you restart the application, all the state will be lost. And obviously that's not ideal if we want to make money of these traffic fines. So let's change this to make sure that we don't lose any of this state. Now, I'm first going to store this state in a Redis cache, as we've done before, and then I'll finally show you how you can easily switch out that Redis cache and go to a different store without touching any code. Okay, if you go to this Dapr components folder, then here we've got our configuration for the state store, which is basically just a copy of the one that you get for free when you run the Dapr init when you install Dapr. So if you look at the type field, state.redis, we've got our Redis connection information here. Now, there's one thing we can add to this configuration, which is not in it yet. We can tighten security a little bit by adding a scope. So this is something you would typically do when you want to harden your application for production. And with this scope added, Dapr ensures that only the traffic control servers is authorized to use this state store. And this component will simply be invisible to all other services. So if I start, let's say, the fine collection servers, and I give it this path for the component directory, the sidecar will see the state store YAML. It will conclude, oh, it's not for me because I'm not in the list of scopes, and it will ignore it. Now, with this configuration set up, now let's create a new implementation of the repository interface that actually uses this state store. And I'm going to call that Dapper vehicle state repository. So let's create a new class, repository. I always make a spelling error when I try to type repository. Then add some code to that. All right, so let's go through this. There's not much in here yet, it's only 24 lines of code now. So this class implements, of course, our repository interface. And then we've got this private constant containing the name of the state store component that we want to use. And then we've got these get and save methods that we still need to implement. Now, in that first demo where I've already showed you state management, I showed you how you can work with Dapper state management directly from an ASP.NET controller. And if you remember, we used model bindings to automatically load those state entry objects from the state store. Now, in this case, we are not directly inside an ASP.NET controller. So it's a bit of a different scenario because now we've got that vehicle state repository abstraction. So here we will use a different strategy, and we will use the Dapper client class to interact with the state management API. So let's start by injecting an instance of the Dapper client class into this repository class. So I've created a field to store the instance, and then I'm using constructor injection to request an instance and save it in that field. And now we can implement our get vehicle state async methods. And of course, I've also got a snippet for that one. So here we call the Dapper client.getStateAsync method to load the state from the store. I give the type of the state as this generic type parameter so that the SDK will know to what type to deserialize the JSON that it gets back from the store. We pass it the name of the store that we want to use, as well as the key to query on, which in this case is the license number. So this method will return any stored state associated with this key, if it exists. And otherwise, we will just get back the default value for vehicle state, which is nil, and we'll just return that to the caller, let the caller deal with that. Okay, now to implement the right side, it's going to be pretty similar. Here we call now the save state async method of the Dapper client. We again pass in the state store name as the key, and now we also, of course, give it the actual state that we want to store. And this is all the code that we need to implement this repository. Now, as I said before, there are some more advanced things you can do. So, and these are specified using state options. So I can create an additional, I can give an additional parameter here called state options. And there are basically two things that I can configure here. So the first I want to talk about is consistency. And you can choose between eventual consistency or strong consistency. And this setting is applicable to state stores that are distributed themselves, such as Cosmos DB, for example. Now, with eventual consistency, the state store writes the updates to a single replica before returning to the client. And then after that time, the store will asynchronously update any other replicas. With strong consistency, the state store will write the update to all the replicas, or at least a required quorum of replicas before returning to the client. Not all data stores support both consistency levels, and if the option isn't set, then the default behavior is eventual. Then the other option you can set is concurrency mode, where you can choose between first write wins and last write wins. So in a multi-user application, there's of course quite a large chance that multiple users will update the same data concurrently at the same time. And Dapper supports optimized concurrency control to manage that. So last write wins is the default. It's what we are using here in this application. And with that approach, the state store will always allow the update to go through, and it will simply override any existing value. Now, the other approach is optimistic concurrency control using first write wins. And that approach uses e-tags. So an e-tag is a value associated with a specific version of a stored key value pair. And each time that you update that key value pair, the associated e-tag will update as well. So it's like a hash that you can check if anything has changed. So if I wanted to add optimistic concurrency control to this repository, I would need to introduce those e-tags. And that would look a little bit like this. So in my get method, I would need to get the e-tag. So instead of calling get state, I would call get state and e-tag. And that would give me back my state and my e-tag, big surprise. So then I would not only return vehicle state from this method, but I would also need to include the e-tag and give it to the caller. And then when saving the state, the caller could pass in that e-tag to my save vehicle state method, and I would use that method to check if I should override it or not. So, and I can do that using this try save state async method on the Dapper client, which takes that e-tag as well as the state I want to write. And this call will only succeed if that e-tag in the store is still the same as the e-tag that I'm passing in here. So that's how you would do that. Let me clean this up because, as I said, our application is pretty simple. It just uses last write wins, and that's the default, and we don't need any e-tags for that. So let me take it back to this status. Okay, so now we need to make sure that our application actually uses this new repository. Let's go to the startup class. Let's find where the old repository was registered. That's over here on line 28. And let's change that to Dapper vehicle state repository. And now we're ready to run the application. So let me start the traffic service. That is running. And let me see, what else do we need? Are these running? Yeah, my vehicle service was already running. My file collection service was also already running. I'm not sure if Edwin already mentioned that. He probably did. This error message here is a red herring. It's a problem in the latest version. It will go away in the next version of Dapper. So I'm ready to run my simulation. And I should see traffic flowing. Okay, and so this is now using my Redis cache as the persistence mechanism. Let's prove that to you by going into Redis, and we can check that by running the Redis CLI inside the Redis container, and I can do that using a docker execute command. So now we are connected to Redis running inside the container, and if I give it the command keys star, which basically means show me all the keys, then you can see that we've got all the states so far captured in Redis. Now note that these keys have been prefixed by the app ID. So the complete key is the app ID separator and my state key. And this makes it possible to store state from different applications in the same data store without any conflicts. Now let's, oh, and it is funny, you also see here bank AzConf, that's the state from my first demo, for which we of course also used Redis. So let me copy and paste one of these keys, and let's look at the value. I can do that using an hgetAll and then give it a key. And here you can see that we've got all our values in a JSON format. So we've got the license number, the entry timestamp, and the exit timestamp. We could actually optimize this a little bit by not including the license number in the value because we've already got it as the key. All right, so let me get out of Redis and stop the simulation, and then stop this just to be sure. Okay. Now, the cool thing is, of course, we can change configurations to change the underlying infrastructure. So let's change this now to make use of Cosmos DB. So let me switch over to my Azure subscription. You can see I've already created an Azure Cosmos DB account called Traffic State. I can go to my Data Explorer and show you that I've got a camera container in there. And if I go to the items and I create a new query and I execute that query, you can see that it's completely empty. So I'm selecting all the items in that cameras container. It gives me back 0 items. So new Cosmos DB completely empty. Now, to make the switch, I only have to go to my component configuration file. So let's go back to that statestore.yaml configuration file and change the manifest spec. Right? We still want it to be called statestore. We just want this implementation to change to Cosmos. So let me change that to a component of type state.azure.cosmosdb. Then, of course, because this is a different component type, it also requires different metadata. So in this case, I need to give it the URL of the database. I also need to give it the master key. By the way, of course, it's not a good plan to include master keys in plain text configuration files. And Edwin will show you a much better way when we talk about the sequence building block. I need to give the name of the database and the name of the collection or container in Cosmos DB. And with that set up, without changing any code, I can now restart my traffic servers. And if I start it again, it will, of course, load in the latest version of my component. So that's running, and then I can start .NET Run the simulation again. And now it uses Cosmos DB for its storage. And of course, we can see that if we rerun this query, and you can see there are already 8 results. And you can see that exact same value with the entry timestamp, the exit timestamp, now being stored in Cosmos DB documents up in the cloud. So extremely easy to change that underlying infrastructure. And it's especially great if you have some infrastructure in production that's hard to test against. And then you can swap that out for something much more simpler in your development environment. So I think this is really powerful stuff. So yeah, that's the state management building block. And I saw you monitoring the chat, Edwin. Do we have any other topics we need to, or questions we need to discuss before we go off to the next one?
Oh yeah, I already tried to answer them. There was one question if we could use Dapr state management, for instance, for caching responses with ASP.NET Core caching.
Yeah.
And there's no, so as I answered, there's no easy way of integrating with that right now. But of course, you could, of course, implement the distributed cache interface yourself and then use Dapr state management as the backing store.
Yeah.
But there's no easy integration from the SDK right now.
In. Yeah, nothing built in, but pretty easy to build yourself. And it's, I think it would be a nice challenge, a nice scenario to try.
One. Yeah, but that's exactly the sweet spot for this caching. So it's not an actual, like we said, it's not a database, but it's really for caching stuff and all that thing. So yeah, that could be done. And that's a nice,
for basically
nice
any scenario where you've got key value pairs and it's kind of hot state, right? Yep. Don't use it to archive gigabytes, but use it for more lightweight stuff.
Yes.
And you know, one of the things I run into pretty often is that with microservices and with PubSub, you start to want to create like SACAs or process managers that simply need somewhere to quickly store some application state for a while.
Yeah.
And this is perfect for that scenario. Yeah. Okay, so let's switch over to you, Edwin, and let's talk about bindings.
Yes, output bindings to be particular. So I'll try to get my Teams window back. When Teams, why do you switch all the time? It's really annoying. So output bindings. Like we said, there are triggers and bindings, so input and output bindings. And now we're going to look at the output binding part. And how does that work? Well, you see again an application running here with its Dapr sidecar. And if I would want to call an external system, I could do that through an output binding if one exists for that system without needing to know the APIs or without having even a reference to the SDK or something or the library for that external system. So how does that work? I could do a call again on the Dapper sidecar, and in this case, I'm using the bindings API, and I send it some payload. Again, in this URL, there's important information because the send event that you see here in this call, in this URL, that is the name of the component that it's going to use. So the Dapper component has a name, as we saw also with PubSub and with state management. So the name has to correspond with the name in the configuration that you specify here. And if you look at the payload, there's something going on there because you have data, which is obviously the payload that you want to send to this external system, and there's an operation. And these operations, which operations are provided by an output binding, is specified by that output binding. So that can differ per output binding. So we'll go into that a little bit later. When you do that, then the Dapper sidecar will actually call the external system that is configured for this binding and then send the payload. So you see a couple of them on the right. So now it's connected to a Kafka, but it could also be Cosmos, or it could be Twilio or Twitter or Redis, whatever. So all the external systems for which an output binding exists, you can really easily integrate with without having to know its specific APIs or specific intrinsic details. If we try to apply this in our Dapper traffic control example application, then we're looking at this part of the architecture. So the find collection service will use SMTP to send out the speeding tickets to people, and that's why we need the email address of the owner. So this is what we're going to build now in the sample application. Let's go back to Visual Studio Code and start working on this. So we're back in the solution. We see upon now that we have our services in here. And the first thing I'm going to do, before I forget that, because I forgot that in the past, but first I'm going to start my SMTP server. Also, again, as a Docker container on my machine. And I'm using a development mail server that's called MailDev, which is pretty awesome if you want to do some testing with an SMTP server, if you need that. So please look into that. So this is just a standard SMTP server that's out there on the interweb. So I'll start this on my machine. And like I said, it is using port 4025 for accepting SMTP traffic. And it has a convenient, I expose port 4000, which will map to port 80 within the container. It has this convenient inbox that you can use to see which mails were sent through this SMTP server. So that's pretty convenient. So let's look at what we need to do to send an email. Well, first of all, I need to have an output binding component configured so I can use that for my application. So I'm going to use another component configuration file, and I'm going to call that email.yaml. And then I'm going to paste in a snippet to specify the configuration. Again, this is a component. The name that I'm going to use is send mail. And if you remember from the slide that I showed you just now, this is the name that I need to use from my application to use this binding. So this is the link with my application. It is a binding of type SMTP, in this case, version v1. And the metadata, as we've stated before, is specific for this component. So in this case, I need to specify where is my SMTP server running. Well, it's running on my machine. As I just showed you, the port for SMTP traffic is 4025, which I exposed on the container. I have to pass in some credentials, and this is something that's really important. This is not for production purposes, so I don't do any TLS verification between my application and the SMTP server. And this is so important that if you put this flag on true, you will actually get a warning in your Dapper logging that says, okay, I'm going to do this for you, but this is not for production purposes. So that's important to notice here. But because we're doing a demo application now, it's not very important. And then finally, we again scope this SMTP binding to only the find collection service. So only the find collection service is going to use it and is able to use it. So that's the first part. Then I'm going to dive into the code of the find collection service and then the collection controller, because we have to change some stuff in there. So In the collect find method, which is called when by the traffic control service when a speeding violation is detected, I will get the speeding violation in, and then I'm going to do some stuff. And here on the bottom, you see a to-do that we're now going to implement to actually send an email. So the first thing I'm going to do is I'm going to create an email body because I need to have some content that I want to email. And for that, I've created a small helper utility class that creates an email body. It's just an HTML string with some placeholders that will form the body of the email. And I pass in the speeding violation information, the vehicle information, obviously, and a fine string. And why is that a string? Because in the Netherlands, it is if you go above, I think it is 30 kilometers an hour too fast, then you don't just get a fine, but you actually have to appear in court to, and then the prosecutor will set a fine for you. So that's, and then they will also look at your history. So that's not a good thing to be in, not a good situation. But that's why we use a string, and that can either be a certain amount of euros or the string to be determined by the prosecutor. And then this email body is created so that we can send it. The next thing that we need to do, if we want to use this output binding, we have to specify some metadata, because in this case, we're using email. So I have to, for instance, specify what is the sender email address. But even more important, what is the recipient? So what is the to email address? And in this case, I get the owner email address from the vehicle info that is retrieved, as you can see up here. This is the call from the find collection service to the vehicle registration service. And then I have this email address of the owner available. And then for convenience, I also add a subject to the email so the user knows on which road this violation was committed. And then we're ready to actually send the email. So for this, I'm going to invoke my output binding for the SMTP binding. And it's basically the same as we saw before. I'm using the .NET SDK for Dapr right now. So I have on the Dapr client an invoke binding async method that I can call. I have to specify the name of the component. And again, this send mail corresponds to the name of the component that I configured in my component configuration file. I have to specify the operation. In this case, I'm creating an email. It's kind of a CRUD way of specifying these operations. And like I said, you can have different operations. So you can also, and this is a little bit confusing at first, but you could also have an output binding that has a read operation. So just look at the documentation of the bindings within the Dapr documentation. But some output bindings also have a read operation for getting stuff from an external system. But yeah, that's a little bit confusing at first. But in this case, we're sending the email, so we're creating the email. This is pretty self-explanatory. And then we specify the payload, the body, and the metadata. And then Dapr will, for me, call the actual SMTP server through the output binding. Pretty simple, actually. So this is all I need to know. And like I said, I don't need to know any specific SMTP APIs or how to authenticate against this SMTP server. That's all hidden in the configuration. For me, it's just an invoke binding, and that's it. And I'm able to integrate with it. As we've seen before, obviously, I have to specify that I need the Dapr client. So it is available in this method. And for people knowing .NET, this is also something that I could have done through dependency injection in the constructor. I don't know why. Oh, I misplaced the bracket there. I have to add a using statement for the Dapr client. And now wow, I'm really struggling with typing here. And now this Dapr client is available and I can invoke the output binding. So the next thing that I need to do is make sure that this Dapr client is available, as we've seen in earlier demos. So I'm going to add another line here, which registered the Dapr client for dependency injection, and I specify the ports that I want to call my Dapr sidecar on. So that's it. So now I'm able to use this output binding. So let's see how that works. I'm going to start my services again in reverse order. So the vehicle registration service, the find collection service, Here we go. And I'm going to use the traffic control service. And then once everything is up and running, I'm going to run the simulation. And well, it shouldn't be a surprise, but you will see exactly the same as before. We will see the logging come into the traffic control service. And once these fines come into the fine collection service, we will actually see this email come in the MailDev server. So here we go. Let's wait for another one. There you see. So now I'm actually calling the output binding, and this will send the emails over the SMTP server for me. So pretty cool and pretty easy for me without learning any SMTP APIs whatsoever. So with that, Sander, I will give it back to you, and you're going to look at input bindings, the other side of the equations of bindings.
Yes, I sure am.
Did I miss any questions in the chat?
Not yet. I think, yeah, okay. Is there a resource? Okay, so this is another question about eShop on Dapper. Yes, there is some more additional info available. We'll share it at the end of the session. Remind us if we don't at the end of the session.
That's the last slide, so we will show that.
Okay, so yeah, let's about time is ticking along quite fast actually, so let's quickly go to input bindings.
Yes.
So this is the other side of the equation. Output bindings, as Edwin told you, are used to invoke external systems. Input bindings can make your application react to external events. So you can basically think of these as triggers for your code. And of course, again, there are a lot of different components that you can use them. Here are only some of them. Now, let's say you want to trigger your application anytime that a message comes in over Kafka. You would let the sidecar handle that by creating a component configuration file. And then the sidecar does the hard work of connecting and polling for messages. You don't have to deal with that complexity yourself anymore. And then when the message actually comes in, the sidecar will call your application over plain HTTP, and it will also pass that payload from the message. So the main thing here is that this will keep your code free of any SDKs or libraries, because as far as your application is concerned, it's simply waiting for an HTTP invocation, and it doesn't know anything about the complexity of polling for messages and stuff like that. And then Dapper Sidecar will also handle any retries and failure recoveries for you. So up to this point, the camera simulation that we use has just used plain HTTP requests to call the traffic control service. And what we want to do in this next demo is to make sure that the traffic control service also accepts incoming traffic over MQTT. MQTT is an OASIS standard messaging protocol. It's really lightweight. It's also used a lot in IoT scenarios, so that's a pretty good fit for our traffic control cameras. And this is a basic diagram of what MQTT PubSub architecture looks like. I think I've got it from the MQTT webpage. On the left side here, there's a publisher which publishes messages to a specific topic on a broker. And on the right side, there are clients that subscribe to those topics to receive the messages. And if we apply this to our situation, then the camera simulation will publish the messages, so that's the publisher. For the broker, we will use Mosquito, which is a lightweight open source MQTT broker. And then we've only got a single subscriber, which is the traffic control service. And of course, we'll not be sending temperatures, but we'll be sending those camera events. All right, so let's make this work. And let me start off by showing you that I've actually got a Mosquito broker running. So I can request the logs for my Mosquito container. And you can show that it's running and it's ready to accept incoming connections. So let's start by making any necessary changes to this traffic control service, because we've got this traffic control service which has this controller, and by now you've seen these a couple of times. You've got the vehicle exit and the vehicle entry methods, which are accessible over HTTP, and we want to change that to make them accessible over MQTT. Now, to change this to MQTT input bindings, we actually don't have to change anything in the code. Nothing whatsoever. Remember from my diagram that when a Dapr input binding is invoked on the sidecar will simply make an HTTP request. So as far as this controller is concerned, there's no difference. It's just being called over HTTP. It has no knowledge of input bindings whatsoever, and that's the way we like it. What we do have to do, of course, is to add some component configuration files for the input bindings. So let's go to our components folder and create one for the entry cam. Let's call this entry cam YAML, and let's add the configuration to it. All right, so what you see here is this is called entry cam, and this name is important because the Dapr sidecar will use this name to make the call to your application. So this name must be the same as this HTTP route. So that's something that's really important, otherwise this whole thing won't work. Then we say we want a binding of type MQTT, and of course we need to specify some metadata for that, so we need to specify where the mosquito broker is. So that's at port 1883, that's the default MQTT port. Then we also need to give the topic that we want to listen to, which is traffic control / entry cam. And then with MQTT, every consumer or subscriber needs to have a unique ID, and we can just let Dapr generate one for us by using these angle brackets with a UUID between them. And then this is scoped to the traffic control servers, because remember, all the services use the same component folder, but we only want the traffic control servers to actually react to this binding. So therefore, we need to scope it to the traffic control servers. So that's the entry cam. We can do the same for the exit cam events. So I'm going to add, let's see, what did I call this snippet? Exit cam. Oh, exit. There we go. So this is the config for the exit cam, which of course now has a different name, also similar to that endpoint, and it has a different topic because the exit cam messages are flowing through the traffic control / exit cam topic. So that's basically all we have to do for the configuration. So now that we've added that, we can start our traffic control service application and servers. So let's run that. And now we just need a simulation program to send events over MQTT, because I haven't started the simulator yet. Now, we could change this console application that we used earlier, but I think I've got a nice alternative, because I've also written a graphical simulation that runs in a browser and is written in JavaScript, and it's a fun thing to show you. So let me figure out where I've put it. Here, okay. Now let's look at the configuration file that I'm using for this simulation, which is my settings.json. And as you can see here, this visual simulation supports both HTTP and MQTT. And right now it's configured to send events using MQTT. And it will connect to my local mosquito broker over port 9001. It doesn't use the standard MQTT 1883 port because I'm running this from a JavaScript sandbox. So, and I cannot establish a direct MQTT connection. So instead, I need to use MQTT over WebSockets, which I can use from the JavaScript sandbox. And for that, I need to go to port 901, which is the WebSocket port on Mosquito Broker. So I can now start this, and this will start a web application host, which is hosting my my JavaScript application. So I should be able now to go to Chrome and then go to localhost 5000. And you can see all our traffic going down the street there. We can scroll a bit, have some parallax scrolling in there. We can zoom in, zoom out, all kinds of stuff. And sometimes you can see some cars going a bit faster than the other ones. They're all, this is, that black one is going pretty fast. They're all behaving very, very nicely. It's Sunday, of course, so there's a lot of slower moving traffic on the road, I guess. Okay, so this is generating MQTT events, and those are going to the traffic control server. So we should be seeing, and we should see traffic coming in here. Now, when I'm focused here in this window, you don't see it moving. That's because this window pauses whenever I switch. So now that this window is focused again, you can, in the background, you can see the MQTT events being handled by the traffic control servers. So to summarize this, it's really easy to use input bindings. You only need to add a little bit of configuration. You don't need to change any code. So that's really powerful. The Dapr sidecar just takes care of everything. It takes care of connecting to that MQTT broker, subscribes to the messages. When something comes in, it delivers it to your application. So that's I really like this building block. Moving on to the next topic, we've already shown you some configuration files with secrets in them, which is not ideal. So Edwin, tell us how we can work with secrets better than we did up to now. And you are still muted, by the way.
Yeah, I know. I was unmuting.
All right, awesome.
Let me see. Let me share my screen. So here we go.
Yeah, I see it.
Over here. So yeah, cool. That visual demo. That also is very nice if you are doing demos with traffic control. You can see actually the speed demons running on the highway. That's pretty cool. So let's look at secrets management. So as Sander said, you saw already in a couple of configuration files and in code, we also have some secrets hidden in there. Yeah, you don't want those secrets to leak, so you don't want them to push them to GitHub or whatever, so people can access them. So that's why there's a secret management building block. So how does that work? Again, we have an application with a Dapr sidecar, and we can, through the Dapr sidecar, we can request secrets. So we expect these secrets to be stored somewhere safe. And then through the Dapr API, we can say, okay, using the secrets API, I will specify the vault that it's stored in, the name of the vault, to be more precise, and the name of the secret. And as you can see in this slide, there are obviously several products that we can use for securely storing secrets. Azure Key Vault, AWS Secrets Manager, HashiCorp Vault, Google Key Management, but also, for instance, Kubernetes has a secret store by default that you could use. So also here, the main focus of Dapr is abstracting away all the intricate details of these different products that you just want to get the secret, and where it is stored, you don't want to, you don't want to know that. You just want to get the access to the secret securely. So that is how secret management works. One thing to notice is that the key that I specify here, my secret, some of the secret management components or the secret management products, they offer the ability to store multiple secrets in a secret. It's a little bit of a thing you have to notice, but you will also see in the code that sometimes you have to specify the name of the secret and then an additional key within the secret. That's something to keep in mind. But in this case, I will get my secret and then I can access this. Then there's an additional way of using secrets, and I'm going to show you this, but this is purely for demo and for local development, which is just storing these secrets in a local file. And obviously, this is not something that you want to do in production, but for demos, it's really nice to show how this works. So just keep in mind that this is a demo application. So we're back in Visual Studio Code, and we see the code that you now already should recognize, all the different services. And the first things that I'm going to do is I'm going to add a file, because we're going to use the file-based secret management component to the components folder. So I'm going to add a new file, and I'm going to call this secrets.json. So this is just a simple JSON file, and it will contain my secrets. Well, in this case, we're using two secrets. Are basically three secrets and two parts. So there's an SMTP part and a fine calculator part. And they both have this one has a user and a password secret, and this one has a license key. Well, this username and password, those are used for authenticating to the SMTP server by the output binding. I will show you that in a minute. And this license key is used within the fine calculator. And I'm going to show you where this is. So if I go to the fine collection service, you see that it uses a fine calculator to calculate the fine when a speeding violation comes in. Well, this fine calculator is a component that I use, and I will show you here. This is a hard-coded fine calculator. As I said before, this is demo code, so bear with me. But this calculator, you could imagine that this is some kind of a library that you have that needs an API key in order for it to be used. In this case, we just hard-coded a license key with a check in it. But if I don't specify this license key, then I won't be able to use this library. So I then get an error, invalid, or no license key specified. So from my collection controller, I have to specify this key. And right now, I'm getting this key from configuration. So if I now go to my app settings, for instance, you can see that this API key is just specified in the configuration file. And if I push this to GitHub, then this will actually be available to everyone. So that's not what we want. So we want to change this. So those are the two secrets, the username password for SMTP and the file calculator license key. So the next thing that we're going to do, so this is basically our secret store. And again, this is not secure, but this is something that we have to work with for this demo. And now I'm going to use a component to configure the secret store. So I'm going to add a new component configuration file. I'm going to call it secrets file.yaml. And in this YAML file, I'm going to specify this component configuration file. So again, this is a Dapper component configuration file. The name is traffic control secrets, and this is something that we can use later on to specify this secrets component. The type is local file, so this could also be HashiCorp Vault or Azure Key Vault. And then the metadata specifies two things. The first thing is the secrets file that I'm going to use as the source for the secrets. And if you look at this folder, there's a little weird thing going on here, which I have to explain, because this secret.json file actually is in the same folder as this secrets configuration file. But when I specify the path to the secrets file, I have to specify it from the folder that I'm starting the Dapper component from, or the Dapper sidecar from. So when I am, for instance, in my fine collection server folder, I have to specify this components folder by going up one level, then into Dapper, into components, and then there's my secrets file. So that is why this is a relative path to my secrets.json file. So that's something that you need to know. Then there's another thing I need to explain, the nested separator. And this is because if we look at the secret.json file, you see that there are two basically sections in there, the SMTP and the fine calculator section. And by specifying this nested separator, and in this case it's the period, so the dot, I can ask for these passwords by specifying smtp.user or smtp.password and fine calculator.license key. So basically this whole structure is flattened, and the dot or the period is used to create individual unique names. So that's something that you can specify. You could also use an underscore or whatever, but I've used dots in this case. So now I have specified my component, and again with the scope I specify that only the fine collection service can access this secret management component. So now there are basically two ways of using a secret. The first thing is that you in code could use, of course, the Dapper CLI or the Dapper SDK for getting the secret. And that's the first thing that we're going to do. So if we go into the code here, and this is the place where we specify, okay, if we don't have a fine calculator license key, we will get it from the configuration. That is not what we want. So we remove this line and we replace this with this call. So again, we're going to use the Dapper client from the .NET SDK. It has a getSecret async method. And then I have to specify the name of the secret management component I want to use. Again, this corresponds obviously with this name. So this is how I specify it. Then I have to specify the name of the secret that I want. In this case, you see this dot being used as the separator. So fine calculator dot license key. And then I get a result. And then, as I said, there could be multiple secrets within a secret. So I also have to specify the individual secret key within the secret. And in this case, it's just the same. So I just can say find calculator.license key. And this will deliver me the actual API key from my secret management component. Again, obviously, because the Dapr client is used, I have to specify it here so that it is injected. So I'm going to say Dapr client, wow. And then it's injected automatically for me. This Dapr client is already known because we've already used it in the other demos over here. And it is also already registered in my startup, as you can see here. So I don't have to do that anymore. So now I'm done with the collection controller and I get this secret from the secret management component. So that's pretty cool. But there's another cool way of using secrets, and that is using them from another component configuration file. So if I go into this email file, this is the component configuration for my SMTP output binding component. And as you can see here, the default username and password are _username and _password. But the critical thing here is that those are just plain text. They're just part of my code, and that's not what we want. So what we want to do is we want to use the secret management component that we just configured for getting these secrets. Well, we can do that. So what I will do is I will remove this configuration, and then I will replace it with this one. And now you see something different. So what we see here is that we added an auth section in which we specify the secret store that we want to use. Again, this is the name that we specified for it, so now we can find it. And then when we specify the user here in this metadata, instead of just adding a value, we add a secret key ref. And we say, okay, the name is smtp.user and the key is smtp.user. Again, this is because a secret can have multiple secrets in it, but in this case, we only have one. So both are smtp.user. And the same goes for the password. So we specify the password by referencing our secret management component and then specifying the smtp.password secret. So this is how that works. So two ways in code, just using the API with get secrets async, or using secret key refs and a secret store that you specify from your component configuration file.
Yeah, there's a question about that code, Edwin. If you can yes, switch to that little code snippet that you.
Sure.
So do you know what would happen here if you just ask for a secret find calculator, because you've scoped license key to find calculator? So you ask for the find calculator .license key secret. Yep. What would happen if you just enter find calculator? Is it possible to get all the secrets?
I don't know. That's a good question. I haven't tried that before.
Okay.
I don't know if that's possible. Maybe, but
I'm guessing it will return nil because it will not end in a leaf node, and it will say, well, I cannot find a single secret, so here's nothing. But try it out.
We can test that in a moment if that's something that we want. So, but let's first. That's a little bit counterintuitive, but let's first. Let's make this. Let's invalidate our find calculator license key to show you that this actually works. So what I'm going to do now is, again, I'm going to start all the services in reverse order. So the vehicle registration service, the find collection service, which is going to use the secret, traffic control service, and now I'm going to start my simulation. I don't know why I did that.
That's not how you start a simulation, man.
No, that's just the project file. So it's starting now. And now when the first speeding violation comes in, here we go, and I will stop the simulation because it will keep nagging me with errors. You see that something goes wrong here, and if we go through to the exception, we actually see here, okay, the invalid or no license key was specified. So we see that it actually gets this license key from the secrets file through the secret management component. So if we now stop the service and we fix it again, we save the file and restart our service. And now we restart the simulation, and then, yeah, well, you will understand what is going on here. Then it will actually work because it will get the right license key from the secret file. So there we go. So I fixed it. So that is what I wanted to show about secret management. I will try that. So I will just try in a minute to see what happens when I just get the find collection service secret. But for now, let's turn it over to you so you can talk about actors.
Yeah, let's go to actors. Let me share my screen and move back to my PowerPoints and get this other window that you all can see out of the way. And we'll talk about actors, or the actor model. So the actor model is actually pretty old in computer years. It originated in 1973. It was proposed by Carl Hewitt as a conceptual model of concurrent computation. So that's a form of computing in which several computations are executed at the same time. Now, highly parallel computers weren't yet available at that time, but the more recent advancements of multi-core CPUs and distributed systems have made the actor model popular again. So in the actor model, the actor is an independent unit of compute and state, and actors are completely isolated from each other, and they will never share the same memory space. Instead, they communicate with each other by sending messages. And the reason why the actor model makes writing concurrent systems easier is that it provides a turn-based or a single-threaded access model. Now, in this model, multiple actors can run at the same time, but each actor will process received messages one at a time. And this means that you can be sure that at most one thread is active inside an actor at any time. So let's look at this example of a counter actor that simply keeps track of a counter value. And let's assume that there's a message sent to the actor to increase the counter value by 1. So the actor will start executing that operation. But while it's busy doing that, a second message comes in to increase the counter value by 2. However, because of the turn-based model, this second message will be blocked until the first operation is completed. So once that first operation has completed and the counter has been set to 1, only then will the second message be handled, and then the count will be set to 3. Now, in this example, we are executing the same add operation twice, but it's really worth noting that turn-based concurrency is respected even across different method calls. So a single actor instance only does one thing at a time. And having that model means that you don't need any complex locking mechanisms in your code to deal with multi-threading. And that makes writing correct concurrent and parallel systems much easier. Now, actor instances are hosted in your servers. And to provide scalability and reliability, the actor instances are partitioned across all the instances of your servers. So let's say that my actor service is running in a Kubernetes pod and I scaled that pod out to 2 instances. Then the actors in my application will then be partitioned across those 2 service instances. And if something bad happens and one of those partitions fails, then the actors will be moved to a healthy partition. So let's look a bit closer now at how that partitioning works. Now, the Dapper placement service that we saw in the beginning, that was one of the containers that was installed by the Dapper init command. That service is responsible for keeping track of where actors are hosted. So let's say we've got applications A and B. Application B contains an actor type called counter. And when an instance of application B is started, the sidecar registers the supported actor type with the placement service. And the placement service then calculates the updated partitioning information and broadcasts it to all the instances. And each service can then cache and use that partitioning information to find the actor instance. Now, there's a question in the chat about how many actors can we actually run inside a single service instance. And there isn't really an upper limit, a theoretical upper limit. It's going to be entirely dependent on how many of those instances are active at the same time and what you do with them and how many CPU and memory are you having in that service instance. You can host a lot of actor instances. Actors are pretty lightweight, so it's not strange to have a production system running with hundreds of thousands or even millions of actor instances. So let's look at an example of calling an actor instance because we will get into the life cycle of an actor, and that's also important for how many actors are there at a certain moment in time. So let's say we've got this application A that wants to call an actor that's part of application B. Now application B is scaled out to 2 instances, so there are 2 pods. And in the first pod, there's an active actor instance called X. And all these applications have received the updated partitioning information from the Dapper placement service. So now when application A wants to call actor X, it will invoke first an operation on its local sidecar. And the sidecar will use the partitioning information to figure out that, hey, actor X is actually located in pod B1. So let's forward the request to the sidecar in that pod. And then finally, that remote sidecar calls the actor instance. Now let's say application A wants to call a different actor, actor Y. And this is interesting because actor Y isn't part of my diagram yet. However, that call will work perfectly fine because Dapper's implementation is based on the virtual actor pattern, which was originally introduced by Project Orleans. And with the virtual actor pattern, you don't need to explicitly create actors. Actors are instead activated implicitly, and they are placed on the node in the cluster the first time that a message is sent to the actor. Now, that also means that there is some automatic cleanup going on. So when an actor hasn't received any messages in a while, they will be automatically unloaded from memory. Now, no state is lost because all the actor state is safely persistent using the state management building block. So when an actor instance reactivates, its previous state will be restored. So to call an actor named Y, application A again makes a call to its local sidecar. The sidecar uses the partitioning information to find the host for actor Y, which let's say it's pod B2 this time. So the call goes to pod B2, and then the sidecar calls the application, and the application will activate that actor and apply the message to it. So follow-up question in the chat, can we run actor with CPU memory limitation? No, you can. You can only set the CPU memory limitation on the pod itself. And then it depends, because I could have millions of actor instances, but if at any point in time I only have a couple of them activated, maybe a couple of hundreds of them activated, I only need a memory for those couple of hundred. Of course, if you get to a point where you've got many actor instances all active at the same time, yeah, then you start to run into memory problems and you need to add memory to your pod, which isn't that different from an ordinary application which needs a lot of memory. So I think this is enough theory for now. Let's look at some code. Now let's go again. I feel like I start all my demos at the traffic control service, but so it is. Let's start in the same controller method again. So we've got our controller, we've got those entry and exit methods, and we've got our constructor here. And if we look at what kind of state this object has, we have a locker. Okay, that's fine. We have an HTTP client. We actually don't need this anymore. It's a leftover from one of the earlier exercises. What else do we have? We've got our state repository because we need to store some state. We need to perform some logic. So we've got our speeding violation calculator for that. And we need to keep track of the road. So that's also some state. So actually, if you look at this, then the behavior coded in this class fits the actor model pretty well. We have these small units of state that consist of an entry and exit timestamp. Then we have that logic to calculate fines. And finally, all those units are independent from each other because each unit only needs to deal with a single vehicle. So let's see if we can change this implementation to use the actors building block. And we should start by defining an interface for our actors. So I'm first going to create a new folder here called actors, and I'm going to add an interface to that folder. I'm going to call my actor a vehicle actor. So let's call this interface iVehicle actor. And let's add an implementation. So clients will use this interface to invoke operations on the actor. Now, this will not build in its current state. We need to add an additional package to use Dapper actors in C#. That's an additional package in the SDK. So let's do that right now. And that's called, well, actually, there are two packages. So you've got Dapper.actors, which includes the core classes and interfaces. We need to develop actor services. And then you've got Dapper.actors.asp.NET Core, which also provides integration with ASP.NET Core. And we want to use the latter one because we are running our actors from ASP.NET Core. So I'm going to do a .NET add package for that package. And now we have that. And yeah, my IntelliSense also has found out that we've got that package. So this works. Now, this interface contains two methods, one for the entry and one for the exit. And I can simply reuse this vehicle registered object that we already used in the controller. So this is just simple container object that contains the lane and the license number and the timestamp. And this object must be serializable by system text JSON to be used in an actor method. And there are some other constraints as well. So the return type for these operations must be either task or task of T. And if you have a task of T, then type T must be serializable as well. Also, actor methods can have at most one argument. So if you need to pass a lot of data to the actor, you need to create a container object like this vehicle registered object that we've done here. Okay, now let's create an implementation for our interface. So I'm going to add another class, call this vehicle actor.cs, and paste in some code. All right. So all actors must derive from this actor base class that you see here. And note that this constructor takes a host argument of type actor host, and this actor host class represents the host for the actor type within the actor runtime. And we need to pass this argument to the constructor of the actor base class. Now let's implement this first method, this registry entry async method. So this is called 5entry. All right, so first off, I've got some quickly, so let me add the namespaces for that. This one as well. Okay, now note that we didn't inject any locker. We use this locker object, which is exposed by the actor base class, which is really nice. That exposes that, makes it easy for us. Now, the only thing we need to do inside this method is to simply save that vehicle state. And I don't need our custom Dapper vehicle state repository anymore. Instead, I simply use this state manager object, which again is exposed by the actor base class to set the actor state. And then the actor runtime will ensure that this state is persisted for me. Let's look at the second method, 5exit. It's more of the same. So at this point, the vehicle has reached the end of the speed camera zone. And the first thing we do is we need to get the state from the actor. And I use that same state manager object again. Now, this state should always exist, right? Because the cameras should always send an entry message before an exit message. But of course, a lot can go wrong with IoT these days. So we check for it anyway. So we've got this if check, if vehicle state is nil, then throw an exception and just let the client deal with it. But the important thing to note here is that thanks to that turn-based access model, we don't have a race condition here in this check. I don't need to worry about this register entry method updating the state at the same time while I'm validating the state in the register exit method. These two methods will never run at the same time for the same actor instance, so for the same vehicle. And therefore, I don't need to use any explicit locking. I don't need to lock this or use mutexes or anything. I can keep this nice and simple. So we're not completely done with this method yet. We still need to add some logic to it. So here we need that speeding violation calculator to calculate if there's a speeding fine. And then if there is, we need our Dapper client to publish an event to the service bus. But we don't have those dependencies yet. Now, luckily, actors also support dependency injection. So it's pretty simple to set this up. I will just replace my constructor. Oh, 5 constructor. You can see this new constructor again uses the host, but then it also takes in this speeding violation calculator and this Dapper client. So any additional arguments I specify here besides actor host are just resolved using .NET dependency injection. All right, so that's basically everything I have to do. So this is my actor. Now let's go back to the controller, because this is still the place where the requests are coming into the application. And let's change all this code to use the actor. So I'm just going to throw everything away. I'm going to replace it with a new controller implementation, which is a lot simpler and a lot more lightweight. And this new constructor here takes in a iActor proxy factory, and we'll use that object to create the actor clients. So let's see how that works in the vehicle entry method. Now, to invoke an operation on an actor, we first need to be able to address it, right? We need to know where it is before, or how it's called before we can call it. So first off, we need the actor type. So the actor type uniquely identifies the actor implementation across the whole application. So in my case, the actor type is vehicle actor. And by default, the actor type is the name of the implementation class without its namespace. So if you want to customize that, you can add an actor attribute to the implementation class. There you can specify a different name. Now the second part is the actor ID, which you can see on line 26. And that actor ID uniquely identifies an instance of an actor type. So we use the license number as the unique identification for all vehicle actors. Now on this next line, we use that injected proxy factory to create a proxy instance for the actor. And we give it the actor ID, we give it the actor type, and we also specify as a generic type parameter our interface, because that is the way that we want to talk to the actor. So now that gives us a proxy, and we can use that proxy to call those actor methods on it. So in this case, we call register entry async, and we pass in the message that we receive from the HTTP request. Now, remember that Dapper placement service distributes the actor instances across all the Dapper sidecars. So this call could be located, could be a call to an actor that's located on a different node in the network, which would mean it's a call over the network. It will incur some latency. So from a performance standpoint, just always assume that you are making a network call if you are calling a actor. Now the other method implementation is virtually the same thing. The only difference is that now we are calling the register exit operation. Okay, so we're getting pretty close to actually being able to run this thing. We still need to make some change to the startup file because to host actors in ASP.NET Core service, we must add some endpoints to the actor. So I'm going to this endpoint section and add actor endpoints. So this will register some endpoints in our application that the sidecar can use to activate, deactivate, and interact with the actors. And then we also Let me see. We also need to add a using statement. And I think that's simply use or add actors. Services dot. Yeah, it's this one. That should well, I think. Or do we? Oh no! Oh no! No! I need to do it like this. .5 add. Yep. It was the correct method, but you need to configure the options that you get in it. And on those options, you can register your active types. So in this case, I've only got one, which is the vehicle actor. So with all of that set up, we are good to go. Now, before I start this, let's all remember that in my components folder, there is still this original statestore.yaml file, which points to Redis and which says, hey, I can be an actor state store. So what happens is that all the state of my actors will use this state store component automatically. All right, so let's now start this. I've got a vehicle service and the find collection service are already started. So now I can start traffic service. And let's just wait for it a bit. And you can see in the last couple of log lines, you can see some information about placement tables updated version 0, version 1. So when the service started, the Dapper Sidecar registered a vehicle actor type with that Dapper placement service. Then the Dapper placement service calculated the update partitioning info, broadcasted that to all these services. So now also, if I look at the services that were already started, such as the vehicle, I can see that it received those same placement table updates. So now all of my services know where all the actor instances live. And then, of course, I can now run that simulation. Let's actually not run the visual simulation because I need a browser for that. Let's run the normal simulation again. And then we should see start everything work again. So we've got some traffic, go to traffic control service, and we've got some fines. So everything is still working perfectly, but now using that actor model. All right. Okay, so it's a little bit of decision time because I'm looking at the clock right now. We've got about 20 minutes left, and we've got two things that we want to show you. So we've got another demo with actors talking about the timers and reminders. And then Edwin has a very interesting part about observability, which will already be a challenge, I think, if we start with it right now to do it. So actually, my proposal would be to just continue with actors, then do our closing slide for the people who have a hard deadline and really need to go in 20 minutes. And then Edwin and I will continue on with the observability part, because it's all virtual anyway. We've got a recording. So then if you're interested in that part, you can always watch the recording back. So let's do it like that.
Yeah, I agree.
There are two questions in the chat right now. What if there are multiple state stores? Is there a way to pick and choose? Yeah, it's a good question, actually. I haven't looked into that. I would say, no, I'm not actually sure which one. I think you can probably configure it. I think you could probably give the name. A different way to deal with that would be to just use scopes and restrictions to specify which services can find which component. But you can probably also specify it in the SDK. I would have to look at the SDK docs for that. So another question. So here, violation logging will run in parallel for multiple vehicles as actor. Yeah. So all the actors are running in parallel. So that means that there can be multiple vehicle actors active at the same time in parallel, and inside each actor, you've only got at most one thread running at the same time. All right, so let's kill this window. Let's stop my simulation for a bit. Let's also stop the traffic control service, and let's go back to slides. And let's add a new feature to our application. So consider what could have happened if we receive an entry event for a vehicle, but we never receive an exit event within some expected time frame. And let's say we are using guaranteed delivery here, so it's not a bug in the system. Now, obviously, there aren't any exits in our stretch of highway. If there were, we would just add some more cameras to them. So what probably happened is that that vehicle broke down and it's now stopped on the side of the road. So wouldn't it be great if we can detect this inside our actor and then send in some roadside assistance to help the driver along? So how could we implement this? Well, if we define the moment that the vehicle drives under the entry cam as timestamp 0, then we would expect that vehicle to drive under the exit cam at some timestamp x in the future, where x is high enough to give even slow-moving traffic like trucks enough time to reach that exit cam. So maybe we can send a notification to our future self to check if the vehicle needs help if we haven't detected it at that point in time. Now, of course, these notifications should be created and cleaned up for each individual vehicle, so that's quite a lot to keep track of. But fortunately, we've already created an actor to represent a single vehicle. And with the Dapper actor model, it's really easy to schedule notifications inside an actor. And there are actually two different types of notifications that we can use, timers and reminders. And both support the configuration of a due time in the future. The difference lies in the lifetime of the callback registrations. So timers will only stay active as long as the actor is activated. And that means that if no other operations are called on the actor, that the actor will eventually be deactivated and your timer will be stopped. Now, reminders, on the other hand, are persistent. So when an actor is deactivated, the reminder will continue to exist and it will simply reactivate the actor when the reminder time fires. So let's go back to our code and see how we can make this. And let's go to the vehicle actor. Let's close this one, open up this file. Let's close the terminal also to make a little bit of room. And let's go to the register entry. Because once we've registered an entry, we should start to create a reminder to remind us to check on that vehicle in the future. So we can do this by calling the register reminder async method on the actor base class. This method takes 4 parameters. So the first one is the name of the reminder, which is vehicle lost. And it's necessary to name your reminders because you can register multiple reminders in a single actor. Now, the second parameter is used to pass any state to the reminder callback. So this must be a byte array, and anything that you pass in here is available when the reminder fires. And then there are 2 time spent parameters. So the first one is the due time when the reminder must fire. So in this case, I want it to fire in 10 seconds. And then the second one is the time interval between invocations after the first fire. So we only need this reminder to fire once. So I pass in -1 milliseconds to disable the reminder from repeating. So now that this reminder is registered, let's go over to the register exit method. And at this point, well, we know the vehicle has arrived safely, right? Because it was detected by the exit camera. So we can simply unregister from that reminder. We don't need it to fire anymore. And for that, I can use the unregister reminder async method of the base class, and I give it the name of the reminder that I want to unregister from. Now, the final thing to add is the code for what to do when this reminder actually fires. Now, for reminders, my actor must implement the iRemindable interface. And that interface exposes a single method called receive reminder async. And in this method, the first thing I do is I check if it's my vehicle loss reminder. Now, my actor only uses this single reminder, so this check is not really necessary, but you can imagine this being useful if you do use multiple reminders. I then load my vehicle state from that same state manager, and then I use that state to log a warning, hey, we lost track of a vehicle, and send in some imaginary roadside assistance. Now, it's really important to know that both reminders and timers do respect that turn-based access model. So when the reminder fires, this callback will not be executed until any other method invocation or timer reminder callback has finished. Also, the other way around, while this callback is running, no other method invocation or callbacks will be allowed to run. And again, that makes it much easier to write these good concurrent applications. So let's check this out. So let's open my terminal window again. Let's restart the traffic control service. And then I'm going to start the simulation and just let it run for a bit so that we've got some cars on the road. And then I'm going to shut it down, and not all of the cars will have made it to the exit camera yet. And we should be able to, let me kill it. We should be able to see those reminders firing and give us those warnings in the traffic control servers. And here we are, you can see lost track of vehicle, lost track of vehicle. So these are all the reminders that haven't been unregistered by the exit method, and they fire and they lock that. So this is something that would be more difficult to do in our original scenario, because we didn't have that nice unit of a single vehicle yet. But because the actor model gives us this nice model, it's trivial to add this kind of functionality. So yeah, that's actors. I don't know, Edwin, do you have the final slide already available on your screen?
No, if you can go to the end of the presentation and then go back one. That.
Yeah,
because I have observability.
You've got the next thing already. Yeah, that makes sense. Okay, so let's go to actually slide 83, I think.
Yep, that's the last one.
So I will do some copy and paste for you and make all these URLs available in the chat. But basically, at this time, we want to give a huge thank you for joining us on your free Sunday to go through Dapper with us. We always have great fun giving this workshop. I think there were especially some really great questions in the chat this time. So hats off to you for that. That's very cool.
That's why we also went a little bit over time, because you had great questions. So thanks for that.
Yeah, but I think it's worth it in the end if we can have some interaction. So a couple of resources. There was a question about the eShop on Dapper. If there's some kind of reference or ebook for that. There is. It's called Dapper for .NET developers. eShop on Dapper used to be the main sample. We've since then changed that to the Dapper control sample. So most of the chapters in the book talk about the same Dapper traffic control sample that you saw us using today. But there is a whole chapter devoted to eShop on Dapper and how it uses the Dapper building blocks. Other thing that's good to know is that for eShop on Dapper, we are currently in the progress of migrating that to .NET 6. So probably somewhere between mid-November, end of November, we will do a new release and it will all be .NET 6 compatible. Then, of course, you've got the links to Dapper traffic control, links to the Dapper documentation. And if you want to, if you're interested to hear more of us talking to guests and talking about cool Microsoft tech and other related stuff, then you can also go to our youtube.com channel, which is called .Netflix. And then the final thing I want to say was there's a feedback link posted by the organizers just in the chat. So please, we would appreciate it really much if you would take the time to quickly give us some feedback using that form. Did I forget anything, Edwin?
One thing, so there was also a question if we could share the slides, and we will do that through the organization. I cannot share the slides here, but through the organization, we will probably be contacted to share the slides, and we will do that. So we can send the slides. No problem.
We'll make sure that they will get that. Okay. So with that, for those of you that have a strict deadline, thank you so much for joining us, and have a great day. And for those of you that are still interested in seeing a little bit about observability, which is a really interesting topic by itself, Edwin will now guide you through that.
Yes. So I will share my screen. Let me see this one. And then bring back my Teams. Here we go. So yeah, observability. As I stated before, modern systems are quite complex. So we see a lot more running parts, distributed applications consisting of multiple services, microservices. And it's really important to see what's going on. And that's what we call observability. And like I said, especially when something is broken, it's really good if you have a really nice way of pinpointing where the problem is and doing a root cause analysis pretty quick. And then you can start fixing your problem. So if we look at observability, then most of the time we identify 4 categories of telemetry, and telemetry is basically all the stuff that you can get from an application that's running. The first type is distributed tracing, so that's insight into the end-to-end traffic going through your services, which is very important if you have services calling each other. It's really nice if you can just correlate all those calls into a call chain. So that's distributed tracing. We have metrics, and metrics could be functional, obviously, from your application, but also very important metrics around how many CPU am I using, how many memory am I using. So quite performance and resource consumption type metrics is really important for troubleshooting. Then we have logging. We've seen a lot of logging today. Basically, all our demos were, we showed that through the logging that was emitted by the applications and by Dapper. So that's also really important. And then there's something called health. We see a lot of, basically standardized health endpoints that you can use to make sure that you know that your services are up and running. Well, this is a lot, so we could basically do an entire workshop just on observability, and there's lots of different standards going on. But for now, we would like to focus on distributed tracing and metrics, because we think that's some of the most important topics. So first, look at distributed tracing. How that works is that Dapper will use correlation tokens, and it will inject these correlation tokens in each request and each response. And it uses the W3C trace context specification for that, which is a standardized way of doing that. And that's automatically handled by a Dapper sidecar when configured. And I will show you in a minute how you can do that. And this is also, of course, where Dapper can help you tremendously, because all the communication from your application to other parts of your application is handled by the Dapper sidecars. So the Dapper sidecars know what's going on between these services. So it is really well equipped to identifying the traffic between the services. And another cool thing here is what's especially nice with Dapper is that because Dapper does not only do service invocation, but it also does your pub/sub heavy lifting. It also does bindings. It also does state. All that stuff is done by the Dapper sidecar. So it is not only when one service calls another service directly, but also if it calls a service through pub/sub, Dapper is able to incorporate that into this end-to-end call chain, and that is pretty valuable information to have. And basically, you don't need to do anything for that. So if we look at the application as we've built it with HTTP, we haven't changed one line of code to get the information that I'm going to show you in a minute. It's all handled by Dapper. So that's pretty important to mention. And this information that you get from the Dapper sidecars, you can use multiple monitoring backends to visualize and analyze this data. So, for instance, Zipkin, which is installed by default when you use Dapper, but also Jaeger or New Relic are backends that you could use. Here you see an example of 2 services that are using the Dapper sidecars. And in the top right corner, you see a Dapper configuration file. And here you can see you can specify the tracing. And in this case, we use a sampling rate of 1, which will mean that every all the information that is available will be logged, and we're sending everything to a Zipkin endpoint. So in this case, the telemetry is pushed by the Dapper sidecar to some well-defined endpoint. And in this case, it is the endpoint for the Zipkin service that is deployed with Dapper. And that's running on port 9411 and then /API v2 spans, which is the default endpoint that Zipkin uses. So how does distributed tracing work? Well, as I said, these sidecars play a very important role here. So when service A calls service B, for instance, this call goes through both the sidecar of service A and the sidecar of service B. And when this call is made, then the sidecar can emit telemetry about this call. And it will inject some kind of a correlation token, a trace ID, W3C trace ID, into the call chain. And it does it using headers. And when this happens, this telemetry is pushed to Zipkin, and then a trace is being created. And a trace is basically an end-to-end call between several components. And within a trace, you can have one or multiple spans. And a span is basically one request-response pair within a call chain. Then when, for instance, service B, as a response of this request that came in, calls service C, the same thing happens. So when the sidecar container of service B puts this request and sends it to service C, it will add information, and by using the correlation token that's already in the request that came in, and it will forward that to service C, the information is expanded. So we see that span A to B will expand because it's part of that request response, because the response did not go back from service B to service A yet. And a new span has been started between service B and service C. And then when the response comes back, the same thing happens. And we can see that these spans are again expanded. And then when the response goes back to service A, basically the span from B to C is done, and the span from A to B will be expanded, and then the entire trace is done. And because this telemetry is pushed to Zipkin with timestamp information, you can also see how much time each of this request and response pairs took. So you can also pinpoint slow services within a call chain with this information. So this is pretty cool. So let me show you how that works. I go to my Visual Studio Code again. And now, excuse me, now we're going to look at a little bit different way of running the application. So until now, we have used the self-hosted way of running the application, but this is running in Kubernetes. So I have here a Kubernetes folder, and this Kubernetes folder contains all the files that I need to run the entire application, including all the Dapper components. So you see the exit cam, the entry cam, the email component, and this is just the component configuration files that you saw before, but now we use these to run it in Kubernetes. Next to all the services, you also see all the infrastructural components, so my RabbitMQ component and my Redis, but also a Zipkin server, and this is important because Zipkin is installed by default when you do Dapper init for self-hosted scenarios, but because I'm now running inside Kubernetes in my own namespace, so everything is running in the Dapper traffic control namespace, I also deploy a Zipkin server. And I exposed this Zipkin server with a service on port 32411 on my host. So I'm able to access this Zipkin server from my machine. And then the last thing I'm going to show you is the Dapper configuration file, which is used for starting everything. And you see here that tracing is enabled, sampling rate is 1, and this is the endpoint address of the Zipkin server, which runs in my Kubernetes cluster. Well, the application is running, so I'm opening up a dashboard here. This is K9S, which is a pretty cool tool for looking at your Kubernetes cluster. And you see all the services here. So you see the find collection service, your mail service, my simulation, but also the Zipkin server. So everything is up and running. And now when I connect to this Zipkin server, so I go to localhost and then this port 342 of 32411, I access my Zipkin servers. And now when I run a query, I can see all the requests and responses going through my system. So in the back, my simulation is running and it's sending messages back and forth. And if I open the first one, you actually see that this is a trace with a certain ID. And this trace contains the traffic control service, the find collection service, and the vehicle registration service, which is basically the entire call chain from the front to the back. And if I show this one and dive into the details, you actually, and this is pretty cool. The first time I saw this, I was really, amazed by how cool this is, because without doing anything in my application, I can completely follow this entire call chain over multiple communications mechanisms. So first of all, I see the input binding coming in. So this is the bindings exit cam. And this is, for instance, you can also see that this is a binding. And it is called exit cam, and it has posted on my /exit cam endpoint on the traffic control service. Then you see the get state and the save state. Then you can see the published event to the RabbitMQ broker. Then you can see the find collection service responding to this message. So it has a subscription on the speeding violation topic. And then from the find collection service, you can also then see the service invocation call to the vehicle registration service. And then eventually even, this is, for instance, the invoke binding, the send mail binding to the mail server, to the SMTP server. So I am able to follow this entire call chain from beginning to end. I get all kinds of information about how much time each of these steps took. And this way I can get really great insight into what's going on within the application. So that's pretty cool stuff. So that is distributed tracing. Then we're going to look at metrics. And
Edwin,
like I said,
Edwin, before you wrap up tracing, so can we use Elastic as a replacement instead of Zipkin?
Well, yeah, I think you could. I'm not sure whether, because it is also using a Zipkin protocol. So like I said, Jaeger accepts Zipkin, but I think that Elastic can also be configured to ingest Zipkin style metrics or tracing.
Right, because Zipkin is both this UI, but also its own standard, right? So if you think that get Zipkin would work, there are also hard at work for supporting OpenTelemetry. So I think eventually, I'm not sure if it's in there yet, but eventually you would be able to choose between Zipkin or OpenTelemetry.
Yeah, that's already possible.
Yeah, it's already is? Okay, yeah. Because OpenTelemetry is it GA yet, or is it still... There's still a lot going on in the OpenTelemetry space.
OpenTelemetry is, of course, the standard, but there's lots of libraries, and also Dapper already has some support for OpenTelemetry. It's not, I think it's not implemented all the way yet, but a lot is already there. And just keep an eye on the documentation, because this changes with every release. We get new features in there. But yes, you will be able to also use different standards than Zipkin. Yeah.
All right. Thank you.
So that was to distributed tracing. Now let's look at metrics. And like I said, metrics is really important to keep an eye on the resource consumption of your entire application. Metrics are also automatically collected by your Dapper sidecar, so you don't have to do anything from your code. And what it does is it will use Prometheus as one of the standards also, and it will use Prometheus for exposing this data. And then within Dapper, by default, you have several levels of metrics. So you can have metrics on the Dapper system services, so the Dapper placement services or the Dapper sidecar injector that are running within your Kubernetes cluster. You can have information from the sidecars from your individual services. And you can have information if you are using those on actors. So if you would use your actor version that you just showed, you will get information on the Dapper actors and how much resources they are using. Like I said, it is using Prometheus, so all the monitoring backend that are compatible with Prometheus you can use for ingesting and visualizing this metrics information. So Prometheus, Grafana, Azure Monitor, New Relic, and yeah, there will probably be a lot more. Maybe even Elk Stack, because it's also metrics that you can put into there. Also, again, what I'm now going to show you, we didn't change anything within the application. If you would like to push custom metrics from your application and include them in these metrics, then you have to do that yourself. So you then have to make sure that you make your metrics available through the Prometheus endpoint, and then these will be included in there. So how does that work? Again, here you see an application with multiple services. And this is a little bit different than with Zipkin. So from Zipkin, the sidecar containers pushed the data to a certain endpoint. With metrics, it works a little bit differently. So if you see in the top right, you see the configuration metric enabled is true. This is the default, by the way. So if you don't specify this, it will be true, but you can disable it. And then you need some Prometheus server running in your Kubernetes cluster in this case to start scraping default endpoints that will be provided by the Dapper Sidecar. So this is not a push, but a pull model. So the Prometheus service will call your Dapper Sidecar. Actually, it will find your Dapper Sidecars by using, in this case, Kubernetes services, naming services. So if a new service is started with the Dapper Sidecar, it will be picked up by Prometheus and it will start scraping the metrics endpoint for metrics. So that's all automatically. And then once your Prometheus scraper is scraping the data from your services, then you can install some monitoring backend. Well, in this case, I'm using Grafana. I will show you Grafana in a minute. And then what you can do in this monitoring backend, you can specify Prometheus as the data source. And once you have done that, then all the metrics will be flowing into your observability backend or your monitoring backend. And then within Grafana, you can specify certain dashboards that are available from the Dapper repositories. And this will give you insights into what's going on with your Dapper application. So let me show you how that works. I have the, if I go to Visual Studio Code, within the solution, I have some scripts that I've used to install Grafana and let me grab that one real quick to install Grafana and Prometheus. So this is some script. I won't go to the entire script because this is all completely described in the documentation of Dapper. So you can find all the information here, but I just created a script for that. It's part of the repository, so you can use that. And if I now, for instance, say give me some information in the Dapper monitoring namespace, these are the deployments that are running. So you see a Prometheus server, you see Grafana, so you see, so everything is up and running within the Kubernetes cluster on my machine. So that's already there. So what I now can do is I can port forward traffic from my local machine to port 8080, which will hit port 80 within my Grafana container. So this is for making sure that I can access my Grafana dashboard. And if I now go to my browser and I will open my Grafana dashboard, I can close this one actually, and go to localhost 8080, you see that I hit my Grafana endpoint, and then I can log on. I already created an account with a password. And this is my Grafana. What I haven't done yet is I haven't specified my data sources. That's the first thing I'm going to do. So I'm going to the data sources within Grafana, and I'm going to add one. And I see I have several data sources that I can select, but I will select Prometheus because that's what we're using here for our metrics. So I'll select that one. I'll name it Dapper, and I specify the name of the server that is my Prometheus server within the cluster. And I already have this address as a snippet. Again, this is all completely described in the documentation. That's why I go through this quite quickly. And then I say save and test, and yeah, everything is green, so my data source is working. So actually, my events are already coming into Grafana, or they are already available, but I cannot see them yet because I don't have any dashboards. So I now will go to my dashboard management, and I will import a dashboard. And a dashboard is basically just a definition, a JSON definition. And within my solution, I have the default definitions that come with Dapper. So these you can download from the Dapper repository. So first of all, let's go to the system services. And like I said, it is just a bunch of JSON that defines, well, a lot. I don't want to go into this, but I'm glad that someone did this for me. And I paste it in. And then I'm importing it. And here you go. So if I look at, let's say, the last 10 minutes or the last 15 minutes, you see all kinds of telemetry about the services that run within my Kubernetes cluster. That is basically the Dapper control plane. So I see my Dapper operator, I see the placement server, the Dapper Sentry for security and certificate stuff, and the Sidecar injector. So I have uptime, I have CPU usage, I have memory usage, the number of Go routines running. yeah, there's lots of stuff going on here. There's too much to go through right now. But the second thing I want to show you, and then I'm going to insert one more dashboard. I'm going to import this. And this is actually the Dapper Sidecar dashboard. And this is also very interesting, because if I import that one and I'm showing it, then you actually see that because I have telemetry flowing in, metrics from my services in the Dapper traffic control namespace, you actually see all these services. And now I'm looking at the find collection service. So I see the Sidecar uptime. I see the CPU usage of my Sidecar. I see requests coming in. I see latency, all kinds of really important information about the Dapper Sidecar. You can see which components are loaded. Now, if I would do actor stuff, then I would do I see actor information here, some security stuff. Well, like I said, it's a lot of information here, way too much to go through right now. And then actually you can also say, well, give me information on all the services, and it will create for you some kind of a combined dashboard, which you can use to see what's going on within your application. So pretty valuable stuff. So with that, we're done. That was all that we wanted to show you. Let's see, how many minutes are we over time? Quite some, I think.
12.
Yeah, 12.
12 and counting.
12 and counting, yeah.
So I just answered the last question, which is, how will Prometheus keep up if the services scale up and down behind a load balancer? Because of course Prometheus needs to scrape your endpoint, so it needs to know where the endpoint is. But
exactly.
But that's a problem you have anyway, whether you're using Dapr or not. And the way that Prometheus deals with that is you can configure different service discovery strategies of how Prometheus will find out which services there are. So that's a feature of Prometheus. That
and you can scale it out entirely, because it's just Docker containers. So you can create scalability sets within Kubernetes and then run multiple Prometheus services. Yeah, so you can scale that out. Great question.
All right. So we're over time already. Let's take 2 or 3 minutes to see if there are any last questions that need to be asked right now. Otherwise, our Twitter handles are on the slide. So you can always reach out to us through Twitter. Another reminder to please fill in the feedback form. And I hope you enjoyed this session. And thank you so much again for joining us on this Sunday.
Awesome.